Are you ready to take your data analytics to the next level? Introducing the Alteryx Essentials course brought to you by the Industry Portal. In today's fast-paced world, staying ahead in data analytics is more important than ever. That's where Alteryx comes in. This powerful, low-code platform enables users to automate data processes, transform raw data into meaningful insights, and dramatically improve efficiency, all without writing a single line of code. Whether you're brand new to Alteryx or looking to sharpen your skills, this course will give you a strong foundation in using Alteryx Designer to tackle real-world data challenges. By the end, you'll be able to build and optimize workflows for data preparation, blending, and transformation. You'll be able to apply best practices to use Alteryx effectively across different business scenarios. You'll be able to leverage Alteryx as a low-code, no-code solution, making it perfect for professionals without a technical background. And you'll feel confident in adding Alteryx to your CV and discussing it in job interviews. Now, we know there's a lot to cover, so we've broken everything down into bite-sized, easy-to-follow lessons. And the best part, you'll have lifetime access, so you can revisit any section whenever you need to. You can even adjust the playback speed to match your learning style. It's no secret that Alteryx is an incredible tool that empowers professionals to create complex data workflows without writing a single line of code. This makes it a game changer for anyone looking to improve business processes, automate manual, time-consuming tasks, and make smarter, data-driven decisions. Many organizations are adopting Alteryx to support citizen developers. Professionals in fields like finance and operations who may not have a background in coding but can still harness the power of automation. I've personally seen tasks that once took over 100 hours reduced to just seconds with Alteryx. With lifetime access to high-quality training videos, a course curriculum that is continuously updated with new learning material, and a dedicated support team if you ever get stuck, you will put yourself on the path to becoming a data analytics pro. Get Alteryx added to your CV and take the next step in your data analytics journey today. It's a software you will not regret learning, and we'll be here to support you every step of the way. I hope to see you inside the course. Hi there, and welcome to the Alteryx Essentials course brought to you by the Industry Portal. I'm so excited you've decided to join me in this course in what I hope is a very rewarding journey for you. In this session, we're going to explore what Alteryx is, why it's such a powerful tool for data analytics and automation, and what you'll learn throughout the course. Whether you're new to Alteryx or looking to refine your skills, this course will provide you with the knowledge and hands-on experience to work with data more efficiently. Now, Alteryx is a self-service analytics platform designed to help users connect to, clean, transform, and analyze data without needing advanced coding skills. It's widely used for data preparation, blending, and automation, allowing businesses and analysts to save time and improve efficiency. With its intuitive drag-and-drop interface, Alteryx makes complex data tasks more accessible to everyone, from beginners to advanced users. Throughout this course, you'll start by getting familiar with the Alteryx Designer interface, learning how to navigate the workflow canvas and the tool palette. Then, you'll dive into data input and preparation, where you'll learn how to connect to different data sources such as Excel, databases, and text files. You'll also explore essential data cleansing techniques like filtering, selecting, and standardizing data to ensure accuracy and consistency. Once you have a strong foundation in data preparation, you'll move on to transformation and blending. You'll learn how to merge datasets using joins and unions, restructure and parse data, and perform aggregations and summarizations to extract meaningful insights. Next, we'll explore data analysis techniques. Whether you're working with basic analytics or more advanced predictive modeling, you'll understand how to leverage Alteryx to uncover valuable insights. You'll also get tips on best practices and preparation for the Alteryx certification, helping you validate your skills and take your expertise to the next level. By mastering Alteryx, you'll be able to handle large datasets with ease, automate tedious data tasks, and integrate seamlessly with tools like Excel, SQL, Tableau, and Power BI. This means less time spent on manual work and more time focusing on insights and decision making. Now that you have an overview of what's ahead, let's get started with the first session where we'll dive into the Alteryx Designer interface and begin building our first workflow. Okay, so welcome to the Alteryx Designer user interface where we create our workflows. So to break things down to the core features, we can really split the interface into 4 distinct sections. At the top we have what is known as the tool palette, which unsurprisingly contains a list of tools that you can use when constructing your workflows. And as you can see, the tools have been bucketed into different categories depending on the functionality that each tool performs. For example, here we have the set of in-out tools that help address data sourcing and data output tasks. So you're going to be using these tools whenever you are trying to connect to data or are trying to produce an output ready for onward consumption. Next, we have the preparation tools, where you can cleanse data, for example, remove white space from your raw data, you can filter data, you can even create new columns of data that do not reside in the raw data set, but is predicated on an underlying formula or calculation. Next, we have tools that help with joining data, we have tools that help with transforming data, and so on. Now on the surface this may not seem like many tools, but if we click on the little plus icon just to the right hand side of these tools, we are presented with so many more. For example, we have tools that help with reporting, like creating automated email distributions. We have spatial tools that help us work with spatial data, for example, working with geographic data. We even have developer tools in which we can integrate languages such as Python. Now you will obviously not use all of these tools in a single workflow. In fact, there will likely be tools you never touch as you will not have a use case for them. But for tools that you use more frequently, you can click the little star button which puts the tool into your favourites. So when it comes to locating the tool in future, you can simply come to your favourites and drag it in from there. Now as you may have noticed, the tools are colour-coded, which can help us quickly identify the different stages of the workflow at a high level. So when you see dark blue tools on the page, for example, you know that it's performing some kind of preparation-based activity. Now one of the great things about Alteryx is its in-application help options. So let's say you were stuck and you didn't know what a specific tool did. You can click on a tool and it will bring up a short description as to what the function does, which will hopefully answer your question as to whether the tool is appropriate to address your problem statement. Now if you need further help, you can always click on the Open Example button, which brings up a new page that shows how the specific tool in question can be used in a variety of examples. You can also right-click on the tool and then select Help, which will open up the formal Alteryx documentation and will then explain how the tool works in more detail. Now finally, in the top right-hand corner, you have the search feature, which has 2 main benefits. Firstly, you can search for words that may help in addressing your problem. For example, let's say we wanted to filter our data but didn't know how to go about doing this. We can search for filter data and it comes up with different help options. You can see here that it brings back tools that may address your problem. It also brings back help documentation as well as snippets from the Alteryx community that may have had problems addressed previously to help you learn and interact with the community directly from the designer application itself. A very powerful feature, and it's something that I use a lot to help address bumps in the road when creating my Alteryx workflows. The next important section of the interface is known as the canvas. Now the canvas is the area in which you will drag and drop the tools from the tool palette to create your workflows. So let's create a very simple example. So firstly, we will drag an input tool onto the canvas by locating it in our tool palette and then dragging and dropping it onto the canvas. Now each tool will have different elements that you can configure, and it's in the configuration window on the left hand side where you can tailor the configuration settings to meet your needs. You can also use the configuration window to annotate your tools so that you can create a very clean audit trail that enables any user or observer of your workflow to easily understand what each stage of the workflow is doing. Now, depending on the tool you are using will depend on the configuration options available to you. So seeing as we've dragged in an input tool, we are being asked to provide it a file or connect a file or database. So what I can do is then search for this file, and in this example I will connect to an Excel file that showcases some Spotify statistics. Now throughout the course we'll be exploring so many tools independently and how we can run them in conjunction with each other to create some really nice dynamic workflows that can help in automating solutions. So once we've selected our dataset, we are given more options in the configuration window. For example, we can choose where the data starts from, i.e. what row. We can also see a snippet of what our data looks like, showing the rows and columns of information. Now to create a workflow, we need to join tools together, and you will notice that tools have either an output anchor, an input anchor, or both. Now linking tools creates a sequence of operations. So let's now suppose we didn't need to see all of the fields in the dataset, and we only wanted to see a few of them. We can use a preparation tool known as Select, which will allow us to select columns from the data source. Now, if you drag a tool close enough to a previous tool, Alteryx will establish a connection link for you, without you having to manually create the connection. But if the connection has not been established after dragging onto the canvas, you can connect tools by clicking the output anchor of one tool like so and dragging it across to the input anchor of another. Now for the purposes of this example, I'm simply going to select 5 columns of data that I find interesting from the raw dataset. Now finally, to browse the result of our workflow at this stage, we can use a browse tool. Now we can drag and drop as previously seen, or we can actually right click on the previous tool and then select Add Browse After. We can also search for a tool and drag and drop from the search results directly onto the canvas. If you create a connection that you no longer want to establish, simply right click on the connection line and select Delete Connection. Now when we want to run our workflow, we can select the blue Run button in the top right corner, or alternatively we can press Ctrl+R, which will also run the workflow. Once the workflow has finished running, you will be able to observe the output, which brings us to the final section of the interface known as the results window. Now the results window gives you information about the workflow status, as well as the ability to see the results of your workflow at different stages. Now keeping an eye on your data and data structure throughout the workflow will help ensure that the workflow is producing results in line with your expectation. So in summary, the tool palette contains a list of tools that you can use in your workflows. When you've identified a tool that you want to use, you can drag it onto the canvas. Linking tools together establishes a chain of operations that will be actioned in sequence on your data. The configuration window is where you can establish the necessary settings for each of your tools, with each tool potentially having different configuration parameters that need to be populated. Finally, you have the results window where you can see the results of your workflow. Now with this in mind, let's start exploring the different tools and their respective configuration settings and showcase how it transforms data to help address various problem statements. In this section, we'll be taking a closer look at the in-out tools, more specifically the tools that enable us to connect to data sources, as well as output data in a variety of formats for onward consumption. For example, we'll be observing how we can connect to Excel and CSV files, as well as connecting to databases. On the flip side, we will also explore different output options, such as outputting to Excel, as well as sending data back to a database. We will also observe how we can output data to visualization software such as Tableau, which allows us to create efficient visualizations. Now, if you've not covered databases in a lot of detail or used Tableau before, don't worry, I will try to make it as clear as possible so that you can follow along easily. If you do have database experience or you've enrolled in my SQL Bootcamp and my Tableau course, you can actually use what you've learnt in these courses to easily control the flow of data between Alteryx, a database, and visualization tools such as Tableau, which can be combined to create some very dynamic solutions. So let's take a look at arguably one of the most important and popular tools in Alteryx, known as input data. Now we can connect to so many different data sources by using the range of inbuilt data connectors that Alteryx has. So let's first of all drag an input tool onto the canvas. Now once we do this, the configuration pane asks us to do one simple thing. It asks us to connect to a file or database, and we can do this by selecting the drop-down arrow here. Now to begin with, we're going to connect to two files, one being an Excel file and one being a CSV file. However, you can see from the list of options below that we can also connect to other files such as JSON files, Microsoft Access databases, ClickView files, as well as Google Earth files. So we have a large list of options when establishing a connection to a file. So let me first of all navigate to the Excel file that I've put together for this simple demonstration called Store. Once I've selected the Excel file of choice, you can see that it's prompting me to select a sheet in which the data resides. Now, seeing as I have two tabs of data in my Excel file, one called Employees and one called Store, I'm getting both in the drop-down list. If I were to have another 20 tabs of data, then I would see this list grow by 20 items. In this example, I'm going to select Employees to see the employees' data. Now, one thing to note here is that you will need to ensure the Excel file you're trying to open is not open elsewhere. If it's open elsewhere, Alteryx will present you with a little error message stating that it's unable to open and read the file. In this instance, simply close the Excel file wherever it's open and re-establish the connection. Once the connection has been established, you will see a few configuration options in the top half, as well as a preview of the first 100 records in the bottom half. Now, seeing as I only have 10 records in this dataset, we are seeing the full picture. Now, the dataset I'm using is clean, with column headers above the data, with the data presented in rows and columns. However, if you're working with data which has no headers, you can select the option which tells Alteryx that the first row contains data. When I do this and hit refresh, you can see that my column headers now become part of the dataset, and the column names have been replaced with F1 to F6, which simply stands for Field 1, Field 2, and so on. Now we can use other tools to rename these columns if we need to, but this will be covered in the preparation section. In this example, the first row doesn't contain data as it represents our column names, so we'll deselect this option and hit refresh. The next option we may need to use is the Start Data Import Online option. Now, if your dataset in Excel is clean, then you will not be using this option much. But let's say that your data starts on row 3, for example. You can change this to 3 and the first 2 records in your Excel file will be ignored. So here if I typed 3, row 3 becomes the headers and row 4 onwards is where the data import starts from. If I were to also select first row contains data, then row 3 would also be part of the data and would not be regarded as the column headers. Now what we have just configured here is the general configuration settings, which is denoted by the little cog symbol, but we have a few more settings which we can observe. Firstly, we have the navigation option, which shows us which tools are connected to the tool in question. Now this is very useful to see when we have multiple tools connected, but seeing as we haven't connected anything to it yet, the view is blank. Now a really useful option available to us is the annotation box, which for me is extremely important to use when attempting to construct easy to follow workflows. So seeing as this tool is being used to input employee data, we will type employee input data. When I click on the canvas, you can see that the annotation underneath the input tool updates, and it's easy to see exactly what this tool is doing. Now we have connected to the data, let's use the Browse tool to analyze it in more detail. Now we can do this by right-clicking on the tool and selecting Add Browse After, which will connect a Browse tool to the right-hand side. When I then run the workflow by clicking on the blue Run button, you can see that the workflow successfully completes in 0.8 seconds. So first things first, if I select the canvas, you will see that we are taken to the messages of the workflow, which tells us the status of the last run. So here we can see that there are 0 errors, 0 conversion errors, and 0 warnings. The run started at 18:59 and 39 seconds and inputted data from this file location. The Browse tool observed 10 records, and it finishes by telling us that the workflow run in 0.8 seconds. Now obviously this is a very small workflow which is not doing anything useful as of yet, but when we add more tools to the canvas, it becomes a very useful piece of feedback for us. Now, if I click on the Browse button, we can see that the data appears in the Results window. And if I select the Metadata tab just next to where it says Data, we can see information pertaining to the data itself. For example, we can see the name of the fields, the data type that each field has, its size, as well as the file path to the file we have connected to. Now, just for completeness, if you wanted to copy the data in the results window into Excel, you can do so by copying the results to the clipboard with either the headers included or not included. Secondly, you can export the results to a file by selecting the little save icon. This can either save all the records in the results pane, or you're able to select specific rows from the results pane to export. Thirdly, we can open results in a new window by selecting this icon here. And lastly, we can revert changes or add tools to the workflow, but more on this later. Now, within the Browse Tool configuration window, we're able to analyze each field to observe different bits of information. For example, data quality issues, or even statistics about numeric fields such as the average or the standard deviation. So at the moment on screen, we can see the profile of the ID field. But if I were to come down to the results window and select on Job Title, which we know is a text field, we can quickly see that an accountant is the most popular job title with a count of 3, sales has a count of 2, and the rest have a count of 1. If I scroll down in the configuration window, we can see data quality checks, which tells us that this field is actually 100% okay, i.e. it does not have any null or empty values. We can see that the shortest job title is 2 characters, which is IT. The longest value is Customer Services with 17 characters, and there are 7 unique values that appear within this column. So straight away we can get a feel for the quality of data before proceeding with the next step of the workflow, whatever that may be. Now, if I click on a field with a numeric data type, such as salary, we're able to see the profile of the salary by record ID, giving us an indication of the spread of data. We can see that the minimum salary is $24,000, with the maximum being $65,000. The average salary is $41,500, and the standard deviation is just over $12,240. So we can obtain a nice picture about the salary of the employees from this Browse Tool output. Okay, so moving on to our second example, we will now connect to a CSV file which I've obtained from Kaggle, and I've included it in the resources section if you wanted to connect to the same dataset. A CSV file is simply a text file which has each of the values in it separated by a comma, which is also known as a delimiter. So once again, we will drag an input data tool onto the canvas. We will select the file we want to connect to. In this case, it's the Spotify dataset in CSV format. Once the connection is established, we get a few configuration options at the top, as well as a preview of the first 100 records underneath. Now note here that the configuration options for a CSV file are different from the configuration options for the Excel file. Now this is to be expected as different file formats will require different considerations. Now one of the most used options when connecting to a CSV file will be the delimiter, as your text file may separate values using a different delimiter such as a semicolon as opposed to a comma. In this example, you would then need to change the comma in this box to a semicolon. Now once we've populated our configuration options, we can add a browse tool afterwards to observe the data in more detail. Now when I run the workflow, you can see that it completes in 0.9 seconds, but this time we're getting feedback that there are 11 field conversion errors. Now this is nothing to be alarmed about, but we'll take a look to see what they are. In the messages section, we can see that the conversion errors are appearing because the field called weeks charted was truncated in 11 records within the dataset. Now this basically means that some text within this field has been chopped off, which wouldn't help if we needed this field for our analysis purposes, so we could extend the size of the data type to ensure that no truncation occurs. Other than this, it appears the data was successfully loaded and the Browse tool has observed 1,556 records. Now just note here that conversion errors and warnings are there to alert you that something is not quite operating as expected. Now this doesn't mean your workflow will break. In fact, you can merely observe the warnings and decide whether you want to proceed or not. Errors, on the other hand, will need to be fixed in order for your workflow to work in its entirety. So let's take a quick look at some of the information in the Spotify dataset. If I click on the Streams field, we can see that it's populated fully. However, we can also see that it's come through as a string data type. so maybe we would want to change this when we perform some cleansing on the data. If we were to look at the artist followers, we can once again see that it's feeding through as a string data type, but this time 0.7% of the fields are empty. Now throughout the course we will continue to explore little tips and tricks we can adopt to help us analyse and navigate the data, but for now, simply note that we can input data by connecting to files from a variety of data sources, and we can configure the tools to bring back the data accordingly. The Browse tool is useful to assess data quality, as well as seeing specific statistics on each field. In the coming videos, we will observe ways of sourcing data across multiple worksheets or files efficiently, as well as connecting to databases. Okay, so in the last video we saw how you could connect to specific files, and we did an example of an Excel file and a CSV file. Now this method allows you to connect to a single file, and more specifically a single tab when working with Excel files. But let's suppose you had an Excel file and it had many tabs of data within it. You don't want to have to drag and drop 5 input data tools onto the canvas for 5 different inputs. Well, fortunately there is a more efficient way of being able to bring in multiple tabs with one input tool. So let's see how this is done. Firstly, we're going to start in the same way by dragging a single input tool onto the canvas. We can then locate the file that we want to import data in from. In this example, I have a file called sales, which shows sales for different regions. Now previously, we selected a sheet to import a specific tab into Alteryx, but this time we're going to select the option that says import only the list of sheet names, and then we'll click OK. When we do this, we end up getting a list of the Excel tab names appearing in the preview window. So we have a tab called England, a tab called Ireland, a tab called Scotland, and a tab called Wales. Now the next thing we need to do is drag in a tool called the Dynamic Input tool. So to find this, we can simply search for it in the search bar, and then we can drag the tool directly onto the canvas from there, joining it to the Input Data tool. Now within the Dynamic Tool configuration options, we need to input a data source template. Now this is very important as it sets out the template that Alteryx will look for when importing the data. Now I've created a clean example here where each tab in the Excel file has the same structure, i.e. the England tab has the same column header names in the same order as the Wales tab, the Scotland tab and the Ireland tab. So we can select any of the sheet names to act as our template. Now because we have the same column headers as well as ordering, Alteryx will simply align the data in each tab underneath the correct columns. If however we had the same names but in a different order, Alteryx will still configure the input, but it will do it by name, aligning the columns accordingly. Now sometimes column headers are different, in which case Alteryx will configure the input to be based on position, i.e. column 1 data will go under column 1 data of another tab, which is why it's always best practice to get your data structures clean, with column names and ordering in the same format. It will save you a lot of time and a lot of hassle. Once we've selected our template, we can simply click OK. Now within the same dynamic input configuration window, we need to tell Alteryx what field to look into from the Input Data tool, which we know only has one field called Sheet Names. So let's go and select this field from the field drop-down list. Now the action we need to select in this example will be the change file/table name, as this will search for the respective tab in Excel if it matches with the list of sheet names in the prior sheet, and input the data accordingly. Now the last thing we are going to do is add a Browse tool after the Dynamic Input tool, so we can observe the results afterwards. When we run the workflow, you can see that it completes in 1 second, and if we were to click onto the canvas and go to the Messages page, you can see that the Dynamic Input tool has gone into each tab and read in the data accordingly, with 76 records being fed in across 4 files, i.e. the tabs in our example. If I click on the Browse tool and scroll down the results window, you can see we have one set of data with England, Ireland, Scotland and Wales all being brought into the dataset, despite being from separate tabs. Now we can click on the sales column and analyse the results across the 4 datasets as if it was one. So hopefully this was useful to see how to bring in multiple tabs of data into one dataset by using a single input tool. In summary, we use the input data tool in conjunction with the dynamic input tool to read in multiple sheets from the same Excel file. We have to provide a template, which is very important as it sets the structure of the data that will be read in. It is best practice to have the format of the sheets identical across each tab in order for Alteryx to configure the input correctly. In other words, the ordering of the columns needs to be the same. Ideally, the names of the columns should also be the same. However, if the column names are slightly different, but the data structure is the same, the input will be done positionally. So try to keep your inputs and data structures as consistent as possible when using this method, to avoid running into nuances with the input. Okay, so in the last video we saw how you could input data from multiple tabs within a single Excel file. So now let's explore a different input use case. Let's suppose you had multiple Excel files and they each contained a tab with data in it which took the same structure. Now once again, you don't want to drag and drop 5 input data tools onto the canvas for 5 different input files and then union them all together manually. That would be far too painful. Fortunately, there is a more efficient way of being able to bring multiple files into a single dataset with one input tool. So let's see how this is done. Firstly, we're going to start in the same way by dragging a single input tool onto the canvas. We can then locate one of the files that we want to import data in from. Now in this example, I have a directory called Sales Files that contains 3 Excel files which show sales for different years. So we have data for 2019 sales, 2020 sales, and 2021 sales. So let's say we wanted to consolidate all of these datasets into one dataset. We simply need to select one of the files. Now as you can see, we only have one sheet in this Excel file, so when ready, simply hit OK. Now at this point, we only have a preview of data that exists for the data in the 2019 file, as our file path is specifically pointing to this file. However, we can now use what is known as the wildcard character, which will force Alteryx to search for file paths that follow similar structures. Now the wildcard character itself can simply be translated to mean any characters. So if we change the year 2019 in our file path and replace it with an asterisk, what this will do is search in the Sales Files directory for files that start with the words sales followed by a hyphen followed by any characters. Now in our Sales Files directory, we had 3 files which had sales followed by a hyphen followed by 2019, 2020 and 2021 respectively. So Alteryx will go into each of these files and pull in the data accordingly. Now the last thing we're going to do is add a browse tool after the input data tool, so we can observe the results afterwards. When we run the workflow, you can see that it completes in 1 second. And if we were to click on the canvas and go to the messages page, you can see that the input data tool has gone into each file and read in the data accordingly, with 57 records being fed in across 3 files. And if I click on the browse tool and scroll down the results window, you can see we have one set of data which shows the results for 2019, 2020 and 2021, all being brought into the dataset despite being from different files. Now there is one other use case I want to show you which takes this capability one step further. Now if I go back into the input data tool and search in the Sales Files directory, you will see that we have a folder called More Sales Files. Now in this folder we have 2 more sales files which show 2017 and 2018 sales. Now despite these being in a different directory, we can still bring these sales files in by selecting an option in the configuration window which you may have spotted previously. What we can tell Alteryx to do is search for files in the subdirectories. Now seeing as More Sales Files is a folder inside of Sales Files, it's considered a subdirectory. So Alteryx will also go searching in this subdirectory for files that start with sales, hyphen, followed by any characters. In this case, it would pick up 2017 and 2018 sales as well. When we click Run, you can see it completes in 1.1 second, and we now get a dataset that incorporates the 2 extra files from the subdirectory. If I click the Browse tool and scroll down, we can see that the sales datasets for 2017 through to 2021 are all included in our single dataset. So hopefully this was useful to see how to bring in multiple files of data into one dataset by using a single input tool. Once again, be mindful of the format of each of the datasets you're bringing in. Try to ensure the column headers and ordering is the same in each file. You should also move files out of the directory that you do not want to include in the input, especially if they take the same data structure, as you will include the data incorrectly. This is because a wildcard search will bring in everything that matches the file path pattern. Just create a new folder and move unwanted files into it. In the next video, I will also show you how this can be done using the dynamic input tool that we've seen previously, to pick and choose what files we want to include without having to move anything. Okay, so in the last video we saw how you could connect to multiple files that reside in the same directory with the use of the wildcard character. We also saw how the input tool can search into subdirectories to bring back files that match the wildcard search. Now sometimes you will find yourself in a situation where you want to input more than one file which may not reside within the same directory, or you may want to obtain files from a directory but not all of them at once, like we saw with the wildcard example. In this video we're going to explore 3 more ways of bringing in data from multiple files, depending on what your use case is. This will be made possible by introducing 3 new tools that we haven't used before, so let's dive straight in. So the first tool we're going to drag onto the canvas is the directory tool. Now we haven't used this tool before, but it resides in the in-out tools, so simply drag it across. Now the configuration window asks us for 2 pieces of input. Firstly, it asks for the directory, i.e. the file path, that you want to bring files in from. Now using the same sales data we saw in the previous video, I will enter here the sales files directory, which resides in my data folder. And just to remind you how this looks, we had 3 Excel files and then a subdirectory with a further 2 sales files within it. The second option in the configuration window for the directory tool is the file specification. Now we will leave this as ***, which basically means all file names of all file formats. But if you wanted to specify a specific file type, for example an Excel file, then you're able to put *.xlsx for example. But seeing as we only have Excel files in this directory, we can leave this as it is. Now when I run the workflow with a single directory tool on the canvas, you can see that the directory tool generates 3 records of data in 1.1 second. Now if I click on the output anchor of the directory tool to see what data it's produced, you can see that we get various columns of information about the files. So we get the full path of each file. We can also see the directory, the file name, and more information related to each file in the directory. Now note here that this only has 3 Excel files and not the files in the subdirectory. This is because we've not selected the Include Subdirectories option in the configuration window, so the 3 records only relate to the 3 files that we have within the Sales Files directory. Now we have the full path for each file, we can once again drag a dynamic input tool onto the canvas and connect it to the directory tool. In the Input Data Source Template option within the configuration window, we will select a file which will represent the data structure of the input. So we can select the Sales 2019 as an example, and as it only has one tab called England, we can simply click OK. We therefore have a template with 6 columns with field names called ID, Year, Category, Product, Sales and Region. Now if you recall from a prior video, when we looked at bringing in multiple tabs within a single Excel file using the dynamic input, we have to select a field that will be read in as our data sources. This was previously just sheet names, but in this example we have a lot more fields that we can choose from, as the directory tool output has a lot more information being fed into the dynamic input tool. For the action, we're going to want Alteryx to change the entire file path in order to point to different file paths of the respective files. Now seeing as each file is in the same file path, albeit with a different file name, this will yield the same result as the wildcard, but you will soon see the flexibility we get when we use this method. The last thing we're going to do is add a browse tool after the dynamic input tool, so we can observe the result afterwards. When we run the workflow, you can see it completes in 0.8 seconds. And if we were to click on the canvas and go to the messages page, you can see that the dynamic input tool has gone into each file path and read in the data accordingly, with 57 records being fed in across 3 files. And if I click on the browse tool and scroll down the results window, you can see we have one set of data which shows the results for 2019, 2020 and 2021 all being brought into the dataset despite being from different files. Now let's add in another consideration into the mix. Let's suppose that we only wanted 2 files to be read in from this directory, not all 3. Well, this could be achieved by using the wildcard option and then renaming the files you don't want to pull in or moving them into a different folder. But this is not best practice, as moving files or changing file names could interfere with other processes that references them. So what can we do? Well, let's first just highlight the current workflow and copy and paste it underneath to create an exact replica of what we just did. Now to see the data from both workflows, I'm going to run the workflow by pressing Ctrl and R, which will run all tools that are on the canvas. Now currently all 3 files are shown in the directory tool, but let's say we just wanted to feed in 2020 and the 2021 file. How do we do this? Well, we could filter out specific rows of data from the directory tool, so that we're left with just the necessary file paths. So let's just move the directory tool over to the right a little bit, and then we will insert a new tool called the filter tool, which forms part of the preparation toolset. Now we will touch on this tool in more detail in the preparation section, but at a high level, what this tool enables us to do is create conditions that split the data into 2 streams. If the data meets the stipulated conditions, it will feed into the true output anchor, i.e. the green arrow that says T, or if rows of data do not meet the stipulated conditions, it will feed into the false anchor. Now our intention is to filter the 2020 and 2021 file paths into the T stream. So in the filter configuration option, we will write a custom filter which states that we want the full path field to equal the 2020 file path, or the full path field to equal the 2021 file path. Now don't worry too much about this for now. Simply note that we're taking an input from the directory tool, which has rows of data in it, and before this data is fed into the dynamic input tool, we are adding in a filter tool which is going to filter out some of the data. Only those records which meet the conditions we stipulate in the filter tool configuration window will feed through into the T stream, which is the output anchor that we'll use when feeding it into the dynamic input tool. When we now run the workflow, it runs in 1.1 second, and we can see a few more messages in the results window. Firstly, we can see that the first directory tool and the subsequent dynamic input tool has read in the 3 files like we know it did from the first example. Now when we look at the second workflow, we can see that only 2 files were read in by the dynamic input tool, 2020 and 2021 respectively. Now just as a side note for navigation purposes, each tool is given an ID, or a name, which is then referenced in the messages window. So if I click on the second directory tool, we can see that this tool is called directory brackets 4. And if I click on the annotation box, we are then able to change the name of this tool accordingly to make it clearer what it is doing. The new name would then feed into the message window. But as of now, if I go back to the messages, you can see that the directory brackets 4 tool is generating 3 records, and the filter is telling us that 2 records were true and 1 was false, hence why we're only getting 2 outputs. If I click on the T anchor, we can see the 2 records accordingly. And if I click on the Browse tool, I can see that we have a single dataset with only the 2020 and 2021 sales data feeding in, whereas the first workflow is feeding in all 3 sets of data. Okay, so we've just seen a way of being able to have more precision with our file path selections, but I just want to show you one more way of stipulating file paths that can replicate what we've just done, but also gives us flexibility to have file paths that are completely different. So once again, we'll copy and paste the first workflow as a starting point. But this time, rather than having a directory tool in which we specify a single directory, we will delete the directory tool by right-clicking and pressing delete, and then replacing it with a new tool known as the text input. Now, the text input tool is essentially a manual input. We are able to create our own tables of data with rows and columns right in the configuration window. We can also paste from the clipboard for tables you want to move from Excel into Alteryx directly, which we'll see in a different video. But for this example, what we're going to do is simply add our file paths to this text input tool. So let's go to one of the file paths, which we can do by clicking on the first directory tool and then selecting a cell in the results window and pressing Ctrl+C. And then we can go back across to the text input and press Ctrl+V in the first row. We will also paste it in for a second time in the second row, but this time relabel this to be 2020. Now, you could put any file path you wanted in this table, which would then be fed into the dynamic input tool. But in this example, I will keep it as 2019 and 2020, so it's slightly different input from the prior example. Also, to keep things clean, I will rename the column header of our text input table to be file paths, which I can do so by simply clicking on the header and relabeling accordingly. Now, in the dynamic input tool, we could leave the template as it is, as we know it takes the same form as other templates. But just to show you that you can also use any template, providing it takes the same format, we will quickly change this template to be the 2020 template. Now, the most important change we need to make is to the field option. Seeing as we've just created a text input with a field called File Paths, we need to change the field to point to this new field called File Paths. The action can be left as Change Entire File Path. When we run the workflow, we can see it completes in 1.3 seconds, and we once again get a few more messages that appear in the results window. At the bottom, we can see that the text input with our specified paths have fed through into the dynamic input tool accordingly. And when we look at the Browse tool and scroll down, we can see that the 2019 and 2020 data is feeding into a single dataset just as expected. So hopefully this was useful to see how to bring in multiple files of data into one dataset by using directory or text inputs to specify file paths. We can also use filter tools to be more specific as to what files we want to see. Once again, you will need to be mindful of the format of each of the datasets you're bringing in. Try to ensure the column headers and ordering are the same in each file. Explore these options on your own machine to really get comfortable with how files can be brought in using different methods. Depending on file structures and what you want to see will sometimes require a different option. Okay, so in the last few videos, we've been looking at how we can bring data into Alteryx that resides in a file of some kind, specifically taking a closer look at the more common file types such as Excel and CSV files. In this video, we'll now turn our attention to connecting to data that resides in a database. Now, I'm aware that some of you may be extremely proficient in SQL and know how to query data from a database, whereas others may have never touched a line of SQL code ever. Now, don't worry, I will try to keep things as simple as possible, but if you're interested in getting set up with a database on your own machine and you want to learn how to query databases using SQL, then feel free to take a look at my SQL Bootcamp course that contains over 11 hours of tutorials to bring you fully up to speed. When you can query data from databases effectively using SQL and also understand how to create workflows using platforms like Alteryx, you can produce some fantastic output that is automated and requires little manual effort, if any. The main thing to get out of this video though is the fact that there are loads more data connectors in Alteryx that you can use. This means that wherever your data sits, you're able to bring them into one workflow and make them speak to each other, even if they're across different formats. This is one of the biggest advantages of using a tool like Alteryx, as those once upon a time disparate data sources can now be joined together. So in the same fashion as connecting to a file, we need to drag and drop an input data tool onto the canvas. Now in the configuration window, you would have already seen that we can connect to a file or database. So let's drop down the option menu and take a look at the database options. In the Files tab, we had a long list of files we can input. But if we select on the Data Sources tab underneath, you can see we get a choice of many databases that we can connect to. So in addition to the frequently used Microsoft SQL Server and Oracle databases, we can connect to MySQL, Impala, Amazon S3, Snowflake, Google BigQuery, Hive, MongoDB, and many more. In this example, I will connect to the same database I used in my SQL course, which is a MySQL database. So I'll come up to where it says MySQL and then select ODBC, which stands for Open Database Connectivity and will enable us to connect to our database. This will bring up a window where it then asks for the MySQL data source name, which you can see is defaulting to the Secure schema within the database as I'd previously set this up. But in order to set up a connection, you would need to select on ODBC admin and then add a data source, which I'm doing through the user DSN. You will simply need to provide some connection details such as the server name, port, and schema to successfully connect, which I'll not be going through in this video. Once the connection has been set up, you can then enter your username and password for your database and then click OK. Now if you're joining to another database, for example an Oracle database, you will have a slightly different configuration window, but it will be asking for similar things, such as an account you want to use that has privileges to the database. When we click OK, we are presented with a window where we can do a few things. We can choose a table that we want to join to that resides in the Secure schema by clicking on the Tables tab, which will just list a set of tables. We can also use the Visual Query Builder where we can establish joins across multiple tables and add further logic if required. The Stored Procedures tab is not something that is supported by this connection. And finally, and in my opinion the best option, is to use the SQL Editor tab. The SQL Editor tab allows us to type in SQL queries that will then be executed to pull back data from the database into Alteryx. Now once again, you will need to have a basic understanding of SQL in order to write simple SQL queries, but hopefully what I'm about to show you is not too difficult to follow. So let's now briefly go across to our database and take a look at some of the data we have in it. On the left hand side within the Schemas section, you can see we have the Secure schema, which is what we are joining to. If I expand Tables, you can see the list of tables. If I expand the Customer table and then expand the Columns section, we can see a list of columns that exist within the table. If I scroll down the tables a bit, you can see we have another table called Payment, which stores payment information related to each customer for the films they've been renting. Now what we will do is write a short query in the database to pull back the data that we want to see, and then we'll copy this query over to our SQL editor in Alteryx. So for our query, what we'll look to obtain is a list of payments that each customer has made. So we'll need to join the Customer table with the Payment table. Now don't worry if this is alien to you, just try to follow the concept. So I'll start by typing select star, which means select all columns, from the Customer table. And we will alias the Customer table to be called C in the rest of the query, so we don't have to type it out every time. Next we will join to the Payment table and alias the Payment table as P. We then have to stipulate what field we want to join the tables on, which is the Customer ID field, as this is the primary key of the Customer table and the foreign key that resides in the Payment table. Now rather than bringing back all fields from both tables, I will actually change this to be all columns from the Customer table, and then I will only bring back the Rental ID column and the Amount column from the joined dataset. When we run this query, you can see that we get a result set below which gives us all the payments that each customer has made. So we can see that Mary Smith has been renting quite a few films, as well as Patricia Johnson. Now I'm happy with this table, and it's the exact dataset that I want to bring into Alteryx. So what I'm now going to do is copy and paste the query from the database UI into Alteryx. Now I'll just tidy the columns up so it's neater to read. And there you have it. We now have an SQL query in Alteryx which will now read from the MySQL database. And seeing as we've tested the query to see what result it brings back, we know we're going to get the dataset that we want. Now if we click on Test Query, we can see that a successful connection was made, so we're not expecting any errors when we click OK. Okay, so now we've made our connection. Before we observe the results, let's take a quick look into the configuration pane to see what other options are available. Now in the Table or Query option is where we can come to edit our query if we want to. If I scroll down, we have some other options which, for example, allow us to execute an SQL query before our query is run, or execute a query after our query is run. Now, why would we want to do that? Well, executing a query before this query is run could be useful if we wanted to delete some data from a database before our query is executed, to ensure that the result is what we want. Now, I predominantly use this when I'm loading data back to the database, to ensure we're not duplicating data that resides in the table, but we'll cover this in more detail in the Output to Database video. Okay, so the final thing we need to do is add a browse tool after our input data tool so that we can see the results. And then we can run the workflow. When we do this, our workflow takes 1 second to run, and you can now see the same dataset in Alteryx within the results window. This data is now ready to be fed into subsequent tools for data preparation, transformation, reporting, and so on. Now, if I click on the canvas to see the messages, you can see that Alteryx has read in 16,049 records in 1 second. If the database had stored over 1 million records, then Alteryx would bring in the full dataset, which is why it can be so powerful for data transformation as opposed to using the traditional spreadsheet tools such as Excel. Okay, great. So in summary, we have connected to a database, in this example a MySQL database, but we can connect to a whole lot more. We have written a query in the database to get a result we want, and then we copied the query into Alteryx. Now, we could have written the query directly in Alteryx, but it's good practice to get a clean dataset as per expectation using the database, as it has much better debugging output if your query is ever wrong. We then simply hit run, which sources the data ready to use in subsequent tools for whatever your use case is. A very neat way of handling large datasets. If you've not covered SQL or databases in a lot of detail, I hope to see you inside my SQL Bootcamp course. Okay, now sometimes there is a need to get some data into your workflow quickly that you want to use for test purposes, or you may want to put a very small dataset in your workflow that doesn't exist in any format, other than on the back of a piece of paper. Now, this is where the text input tool can help, and is the final method of data input we will explore. Now, the text input tool is very basic in terms of how it's configured, so let's see it in action. So firstly, we will drag a text tool onto the canvas, which once again can be found in the In-Out tool category. Now let's assume you have mapping tables in Excel that you want to use in your workflow, but want the ability to change the mappings in Alteryx on the fly. Now I've created very simple mapping tables that I will use in this example, which show the city ID, the name of a city, and the city's population, as well as a second tab which shows some data on people. Now, the configuration window of a text input tool allows us to import data via the import option. We can also copy data from the text tool and paste it outside of the text tool itself. And we can also use the paste option, which allows us to paste data in that we have copied onto the clipboard from another tool. Now, let's first bring in the city table into the text tool by importing the file. So I can click on Import, and I have a few options where I can import from, but in this example, I will select File and then search for the file where the data resides. Once I've selected the file, I can pick the respective tab and then click OK. And there we have it. I now have a set of data in Alteryx via the text input sheet that I can now use in subsequent tools in the workflow. Now note here that when we import, the first row is considered as headers and the rest is data. If I now add a browse tool after the text input and run the workflow, the data is fed in like any other data source and we can now use it accordingly. Now, a slightly different way of getting data into the text tool is by simply copy and pasting it from my file, but it has one noticeable difference. If I drag another text input tool onto the canvas and open up the Excel file example which contains the people data, I can select the data and press Ctrl+C, which will copy the data to the clipboard. And then I can go back into the text tool configuration window and click on the paste option. This copies the data into the text tool. However, notice that the row headers were also considered as data. Now this can be a pain if there are hundreds of column names, but seeing as we only have a small table, we can simply rename the columns manually to the correct headers by clicking on Field 1, Field 2 and Field 3 names respectively and renaming them. Now obviously, seeing as we don't want the headers to be part of the data, we can also select row 1 and then click the delete option and then delete the row. Now if we wanted to add more data to our text input, we can use the insert option like so, where we can insert records to the bottom of our dataset, as well as picking where we want to insert data into our dataset, selecting the row and inserting a row accordingly. We can update the data that resides in the table by clicking on the cells that need changing and making the necessary changes. We can add columns of data by inserting columns just like we can with rows, and then providing the column with a name and adding the data accordingly. And if we add a browse tool after the text input and run the workflow, once again we have a set of data that we can now use in subsequent tools. Now we can also take data from the text input tool and copy it elsewhere. So if I were to select the top left of the table and select copy, I can paste it to a program such as Excel to then use in other processes if required. And just for completeness, I can also copy and paste selected rows of data from the text input tool into Excel like so. So the text tool is a very useful tool if you want to get some data into your workflow in a manual way, as you can start a dataset completely from scratch by creating columns of data and then adding the data to it yourself. Data can also be imported from a file or copied from a file and pasted in accordingly, ready to be used in the next stage of the workflow. Okay, so we are now at the point where we are comfortable to load in data from a variety of data sources into Alteryx. Whether that be data from a file such as an Excel file or a text file, or data directly being pulled in from a database such as a MySQL database, or even data we manually put into a workflow via a text input tool. We have learned how to connect to different files, and all we need to do is simply provide input into some configuration options depending on the file type, and our data will be pulled into Alteryx accordingly. We can now feed this data into subsequent processes. But before we start to perform calculations on the data or conduct some statistical analysis of some kind, we first have to make sure that the data we are using is in a user-friendly format and ready to be used. Now, unfortunately, we do not live in a perfect world, so we have to be mindful that there could be some cleaning up required to get the data into a state fit enough to be used. This is where the data preparation tools come into play, and they are great for helping us clean up some of the data quality issues we may face when looking at the raw data inputs. The first preparation tool we're going to observe is the data cleansing tool, which helps us clean up some of these data quality issues. For example, we may have some white space that appears before or after a specific word that makes joining this data with other tables tricky. Or we may have some columns of data that contain letters and numbers within a product code, but it's only the letters that we need from the code. These issues can be quickly resolved by utilizing the data cleansing tool, so let's see it in action. First things first, we need to input some data. So let's bring in a text input tool, and we will then import some data that I've pre-populated into the tool from a file called data cleansing. Now I've attached this file in the resources section if you want to follow along with a set of data which incorporates some data quality issues, but feel free to create your own. Now if we observe this data set, you can see that we have a column called trailing underscore spaces, which, as the name suggests, is a column containing values followed by some white space. So you can see that John has a couple of spaces after it, and Julie has one space after it. Now simply observing this would be impossible to tell that there is white space following these names, but without removing this white space, it could cause subsequent issues in our process if we utilize these fields in, say, any join conditions later in the workflow. So it's important we clean up this data as much as possible before we progress. Next we have a column called leading underscore trailing, which have last names in the column, but this time with spaces before and after the name Smith and before the name Gill. Next we have a column called punctuation, which simply has an adjective with some punctuation afterwards. Next we have a column called salary, which is 10,000 for John, and I will make Julie's salary an empty cell in the text input, which can simply be translated to mean a null value. Next we have a column called cost, which we can see is in thousands, but the cost has a suffix of the letter K afterwards, which will cause issues if we need to use this field in any calculations. Now this is because the letter K will actually make this field a string data type, but we will cover data types in more detail shortly. Next we have a field called comment, which is a little comment about the performance of each person, and we end with a code which starts with a series of numbers followed by a series of letters and then ends with some numbers. Now this may be exactly how we want the code to be viewed, but we will see an example shortly of how we can remove unwanted characters utilising the data cleanse tool if required. So before performing any data cleansing, let's add a browse tool after the text input tool to see what the profile view is telling us about the data. Okay, so firstly, the trailing spaces column is apparently 100% not okay. Now this should raise alarm bells and we should certainly look to address the data quality issue we see here. If we look more closely, we can see that we have two values with trailing white space. And if we hover over the valid values within the trailing spaces column, Alteryx feeds back to us that this cell has trailing spaces, so we can also see directly from the results window what the issue is. The leading underscore trailing column is also 100% not okay, and we can see in the profile view that we have two values with leading white space, i.e. white space before the names, as well as one field with trailing white space. And if we hover over the values in the results window, we can also see that Smith is the value which has leading and trailing white space, and Gill is the value that has leading spaces. The punctuation field is coming through as OK, as it has no white spaces and simply includes some punctuation characters after the word, which we can keep or remove if we so decide. The salary column is coming through as 50% OK and 50% as null. And if we look in the profile view, we can see that we do indeed have one row which has a null value in it, so we can decide how to treat this shortly. The cost column is coming through as 100% OK, but if you look carefully, you can see that the field is being treated as a field with a data type of string. This is something we may want to address if we plan on using the number in any calculation further down the line. So despite Alteryx telling us that the column is 100% OK, this is purely from a population standpoint, and there could still be some issue with the respective data types and values within the column. The comment field is 100% OK and is simply a string field with some text in each row, so no complaints here. And finally we have the code column, which contains numbers and letters. Okay, so let's see the power of Alteryx to help us in cleaning this dataset from its current state into a more user-friendly input. To do this, we can simply drag a data cleansing tool onto the canvas and join it to the text input tool. So the text input tool's output anchor will be joined to the data cleansing tool's input anchor. And as you can see here, a single tool can feed its data and data structure into multiple input anchors of different tools, which can result in the data being used in different branches performing different operations, which is great for scalability. Okay, so if we look across to the configuration options of the data cleansing tool, you can see we're presented with a table at the top, which asks us to select fields from the data that is feeding into the input anchor that we want to cleanse. Now we're able to pick and choose by using the check boxes, but one piece of advice is to start with performing cleansing actions across all fields. If there are specific columns that require a slightly different cleansing option, we can chain another data cleansing tool afterwards to address that requirement, which I will showcase to you shortly. So in this example, we will start by cleansing all the fields simultaneously. Underneath the field selection box, we have the actions we would like to perform. Firstly, we have the treatment of null values. So if we select the replace with blanks for string fields, null values will be replaced with blank cells. And if we were to select the replace with 0 for numeric fields, nulls become 0. Now you may be asking yourself, what impact will this have on my data? Well, let's say you were wanting to perform an average calculation on the salary column across the entire dataset. If you replace nulls with 0, your average will be 5, as the calculation would divide 10 by 2 rows of data, because it recognises 0 as a valid number. Whereas if you had left them as null, the average calculation ignores null values and would have brought back a result of 10, which is 10 divided by the one row with a valid value in it. So deciding on how you treat nulls is obviously important if you're planning on using them fields later in calculations. So keep this in mind, as depending on what the column represents may warrant a slightly different treatment. The next section deals with removing unwanted characters, including items such as leading and trailing whitespace. So to start with, rather than selecting all items initially, let's just leave the data cleansing tool to replace nulls with blanks and 0 for string and numeric values, and then remove the leading and trailing whitespaces, which we know are present in the first two columns. We will quickly add a browse tool to the data cleansing tool and run the workflow. Okay, so if we now look into the results window as well as the profile pane, we can see that the trailing spaces column no longer contains any issue, and it's 100% okay. We can see that there are 0 values with trailing whitespace, so the data cleansing tool has removed it as per expectation. We can also see that this is the case for the leading _ trailing column. The punctuation column has not been affected by the cleansing tool, but we can see that the salary column is now 100% okay. This is because the null value that we once saw for row 2 has been updated to state 0, which is considered as a valid value and hence is no longer being flagged as a data quality issue. The final 3 columns have been unaffected by the current run of the data cleansing tool. So with one simple tool, we've gone from having an input data source that looked like this to now looking a lot cleaner. But let's see what some of the other options do, so you can observe the result and apply it to any future use case you may have. So firstly, we'll take a look at the all whitespace option. What will this do? Well, removing all whitespace will impact words that are also separated by a space. So if I select this option and rerun the workflow, you can see that the comment column has now changed, and the sentence has come through as one long word with all white spaces removed. This is not what we want in this example, so let's deselect this. The next option will remove all letters from the selected columns. So selecting this and rerunning this workflow will actually give us very little output, seeing as most of our columns are populated with letters. But you can see, for example, in the code column that the letters have been removed, which were once upon a time in between the numbers, but we are now left with just the numbers of the code. You can also see in the cost column that the suffix of k has been removed, which means it only contains numbers and can therefore be changed into a numeric data type for onward consumption. If I remove numbers as well as punctuation and rerun the workflow, unsurprisingly, it's removing them every time they are observed in any of the columns we have selected above, i.e. all of them. So the code column no longer has numbers. We have lost the cost, but the k remains, and in the punctuation column, we are only left with the adjective and no punctuation mark itself. Finally, we have the ability to modify the case of the strings. Now there are 3 casing options. We can change everything to uppercase, we can change everything to lowercase, and we can change everything to title case. So uppercase will change everything into a capital letter. Lowercase will turn everything into a lowercase letter. And title case will change every first character of the word to an uppercase letter. Now note here that the first letters of the code column are not changed, as the original word started with a number which we are removing as per our current configuration options. So the letter A and D are not considered as the first characters of the valid value. But for now, we'll turn off the modify case options as well as the removal of numbers. At this stage, we can rerun the workflow as it completes the first part of the cleansing we want to perform. However, there are a couple of other cleansing operations I would like to perform in this data which do not relate to all columns. So in order to do this, I will drag another data cleansing tool onto the canvas and make sure the output anchor of the first data cleansing tool goes into the input anchor of the second data cleansing tool. Now what I would like to do is address the suffix of k in the cost column. To do this, I need to select the cost column only and then state that I would like the letters to be removed. Now in this example, we do not have any null values, so leaving the replace null option selected is not going to make any difference. When we add a browse tool to the data cleansing tool and then run the workflow, we can see that we get our dataset with the white space removed from all columns as per the first data cleansing tool, which feeds its results into the second data cleansing tool where the K is then removed. You should still note here that the field is treated as a string data type, so we'll need to address this at some point, but this will be covered in the next couple of videos. Now the last thing I want to do is address the final code column, where I want to simply remove the numbers. To do this, I will once again drag another data cleansing tool onto the canvas and connect it to the output anchor of the prior data cleansing tool. We can then select the code column and then select the numbers option from the remove unwanted characters section. We will then add a browse tool and run the workflow. And at this stage, I feel happy with the current format of the table, and the data cleansing tool has done everything it can to address some of the data quality issues that we previously observed. Now, one thing I want to quickly draw your attention to is the metadata of the data that feeds from the output anchor of the final data cleansing tool. Here you can see we have the type of each field, with only the salary column being described as a numeric field, in this case an int16 data type. We will need to change this at some point, as we also know the cost column is a column which holds numeric values. Next to the type, we can see the size of the column, which simply refers to how much space is taken up in memory when working with this data. Now, being mindful of the size is important, as when it comes to working with large data sets, it can improve the efficiency of the workflow dramatically and make things quicker to run. And we will see a very nice tool which helps us optimize the size and type shortly. So in summary, we've taken in a raw dataset which once had numerous data quality issues, as well as fields that needed cleansing in one way or another. We have passed that data through data cleansing tools to arrive at a set of data that is ready to be consumed by subsequent tools. Remember, if required, you can chain multiple data cleansing tools together to achieve your desired result. But it's always best practice to try and get upstream data sources corrected at source rather than having to correct data quality issues through a workflow tool. Now that being said, sometimes the investment to get upstream data sources corrected is far more expensive. So utilising the data cleansing capabilities of a workflow tool like Alteryx can certainly save a significant amount of time and resources. Okay, so in the last video we explored the data cleansing tool, which allows us to clean up some of the data quality issues that we may face upon importing a set of data into Alteryx. So we went from having columns with leading and trailing spaces, null values, and some unwanted characters, which was then passed through 3 data cleansing tools to arrive at a set of data that was clean and ready to be used in subsequent tools. Now, one of the great things about Alteryx is that we're able to observe the output of each tool, so it's easy to see whether the data is being transformed in line with expectation. So if you're ever getting an erroneous result, you can step through the workflow step by step and observe where the issue sits. Now, you may recall from the last video, I showed you the metadata of the data, which shows us information such as the data type of each field, as well as the size that the column can consume for each row. Now, sometimes we may want to change the data type or change the name of the column to something more meaningful. Other times we may want to change the size of the field or even provide a field with a description so we can tell others what the field should be used for. We may even want to change the ordering of the fields or remove some fields so they're not passed to the next stage of the workflow. Now, all of this can be done by using what is known as the select tool, and it's a very useful tool to help manage the data that is passed from one tool to another. So let's take a look at it. So we can locate the select tool in the preparation category and drag it onto the canvas. We will connect this tool to the output anchor of our final data cleansing tool, which means that the final result set is passed to the select tool. When we look into the configuration options for the select tool, we get a very simple table, which on the surface may not look like much, but we can carry out specific operations. Firstly, you can see the columns that have been passed in from the previous tool. In this case, we have these field names, and if I want to remove the fields called punctuation and comment from the dataset before it's passed on to the next tool, we can remove them by deselecting the checkbox like so. Now, you may also want to change the name of the columns to make it clearer what each column represents. Now, we can do this by typing in the new column name within the rename column. So for the trailing spaces column, we will rename this to be first_name. And for the leading_trailing column, we will rename this to be last_name. We will also change the cost column to say cost rather than having the zeros within brackets. Now you will also notice here that we have a star unknown field at the bottom, which is obviously not part of our original dataset. Now this represents any field which may come into the tool which Alteryx did not know about when the module was originally built. So for example, let's say we have a workflow including this select tool, and later down the line we change the raw file and it includes an extra column called bonus. If star unknown is selected, then any new field from the data stream will continue downstream for further processing and potentially be included in your outputs if you've configured it in such a way. Therefore, the field bonus would feed through. If you deselect the star unknown field, then any new field will be dropped. In this case, the bonus field would be included in the raw dataset but would not feed through post this select tool. If we add a browse tool to the output anchor of the select tool and run the workflow, when we look at the data, you can see our fields have been renamed and the punctuation and comment fields have been removed from the output. Now if we take a closer look at the cost column, despite being populated with numbers, we saw in the last video that the data cleansing tool has not changed the data type to reflect the underlying data, as it was previously considered a string due to the inclusion of the letter K. Now the select tool can also be used to change data types if so desired. So in this instance we will select int16 from the drop-down list, as we know we want this field to store numeric data, and int16 represents a short integer value, so is plenty big enough to represent our current cost column. Selecting the appropriate data type for each field is important, as it allows you to perform specific functions on the field in question. For example, you have string functions that enable you to work with string data types, as well as numeric functions that work with numeric data types, same with dates, and so on. So it's best practice to define these up front so they can be used in the rest of the workflow as and when required. If we rerun the workflow and now analyze the cost column, you can now see we have a profile view on the numeric value, which we can see has a standard deviation of just over 1.4. Now the final thing we have the ability to do in the select tool is change the ordering of columns. So as it stands, you can see the data coming through with the code column on the far right hand side. This is because it sits at the bottom of the list. However, if I were to select the code column, right click and drag the column further up the list, for example just before salary, when we rerun the workflow, you can see that the code column has been repositioned accordingly. So the select tool is a very useful tool to use when you want to address the metadata of an incoming dataset. We can change column names, we can change the type and size of a specific column, we can provide a description as to what each field does, and we can also pick and choose what fields we want to progress to the next stage of the workflow. The columns we deselect will not be present in the subsequent tool. In the last video, we took a look at a very useful tool known as the Select tool, which helps to manipulate metadata as well as giving us the ability to pick and choose which columns are fed through to the next stage of the workflow. In this video, I would like to introduce you to the Autofill tool, which is a great tool to help with optimizing the metadata. Now when you include the Autofill tool into a workflow, it automatically sets the string field's data types to the smallest type that will be accommodated, as well as set each string field to the smallest possible size based on the dataset that is fed into the Autofill tool. Now this is great as it ensures that the tool remains as efficient as possible from a data handling perspective and keeps the workflows operating as fast as possible. So let's see it in action. What I will do is move the Select tool and the final Browse tool to the right a bit, and then I will slot in an Autofill tool in the middle by dragging the tool from the Preparation tool palette in between the Data Cleanse and the Select tool. Alteryx will automatically connect the input anchor to the previous tool's output anchor, and it will also do the same for the output anchor to the next tool's input anchor. Now in terms of configuration, there is very little to do. In fact, you just have to select the string columns that you want the auto change of field type to occur on. In this example, we will leave all of our string fields selected. When we run the workflow and then select the metadata that relates to the input anchor of the autofill tool, i.e. the data that was passed in from the final data cleanse tool, you can see that all of our fields are string data types, apart from our salary column. And when we look at the size of each string field, we have fields that contain 6 characters, some are set to store 9, and the comment field accommodates 31 characters. Now if we select the output anchor of the autofill tool, you can see that the data type for the cost column has changed to be byte with the size of 1, and a few of our string fields have reduced in size as the values that are stored in them do not need to contain as many characters. In other words, Alteryx identifies the longest string length and ensures the size of the field is set to this value and no more. So for example, the leading trailing column goes from 9 to 5 and the code column goes from 9 to 3. Now this may all seem relatively small in terms of impact, but when you're dealing with large datasets, it's best practice to ensure you optimize the dataset where possible to ensure the performance is as good as it can be. Now in the select tool, we actually manually changed the data type to be an int16, but Alteryx is telling us that the field, which it recognizes as a numeric field, only contains single-digit numbers, so it has reassigned it to be a byte data type. Therefore we can change this so that we're not subsequently overriding this back to an int16 data type. When we now run the workflow, the select tool is simply changing column names and then deselecting the punctuation and comment columns from the next stage of the workflow. And if we go back to the cost column and analyze the profile, we can see that we have the same statistical analysis of the field feeding through, despite the data type changing to a byte data type. So inputting an autofill tool is great to help switch data types to a type which the values accommodate, as well as reducing the size of each field to a smaller size, which can help produce efficiencies in your flow, especially when working with larger data sets. Just be careful that the autofill tool doesn't change a data type to something else, when in actual fact you want it to be a string data type all along. In this video, we'll take a look at the filter tool, which conceptually is very simple to understand. Now the filter tool will take in a set of data and will evaluate each row of the dataset against a condition or multiple conditions that you stipulate in the filter tool's configuration options. If rows of data meet those conditions, they will then be evaluated to true and the data will feed to the true anchor, which is denoted by the letter T. If the rows of data do not meet the conditions stipulated in the filter tool, they will be evaluated to false and will feed the F output anchor. The datasets that feed the T and the F streams respectively can then be used in subsequent parts of the workflow. Now there are lots of different conditions we could write, but the key thing is to write Boolean expressions, i.e. conditions that result in either a true or false result for each row in order for the tool to work. So let's take a look at how we can use it with a few use cases. Firstly, I will drag an input tool onto the canvas and connect it to a sample dataset called restaurant, which has information on a list of individuals and how much they've spent at restaurants. I have also attached the dataset in the resources section if you'd like to connect to the same dataset yourself. So as you can see, we have 5 columns of data showing first name, last name, age and gender, as well as the dining out expenses for each individual. So if we add a browse tool to this dataset and observe the profile of the dining out expenses column, we can see the smallest value is 2.6 and the largest value is 998.76 with an average of just over 503. Now these statistical observations are based on the entire dataset, so all 283 records are considered in this average calculation. But what if we wanted to conduct a slightly different piece of analysis? Let's say there was a data analyst who was responsible for looking at female expenses, and another analyst was responsible for the male expenses. Well, the filter tool gives us the ability to split this dataset into 2 streams based on the conditions we include in the tool. So we'll first delete the browse tool, and then we'll drag a filter tool onto the canvas so that the output anchor of the dataset is feeding into the input anchor of the filter tool. Now in the configuration window, you will see 2 options. We can firstly create conditions using the basic filter, or we can input conditions based on the custom filter, which is more flexible. Now with the basic filter, you're able to select a column for which you'd like to create a condition for. So using the example of splitting the dataset into male and female streams, let's base our first condition on the gender field. Next, we have a drop-down which allows us to select a comparison operator or function that can either be assessed as true or false. For example, if I were to select equals in this example and then enter the letter F for female in the final box, what we are essentially saying here is Alteryx should go through every row of data in the dataset and look in the gender column. If the gender equals F, then that row should be evaluated as true and should subsequently feed into the T stream of our filter output anchor. Now you can add browse tools to both of these anchors simultaneously by selecting the Add All Browsers option, but we can also add a browse tool to the true or false anchor respectively if you wish. Now when we run the workflow and then select the canvas to bring up the messages window, you can see that the input has pulled in 283 records, of which 139 records evaluated to true, meaning that 139 records were populated with the letter F in the gender column, and 144 evaluated to false. If we click on the Browse tool off of the T anchor, you can see that our dataset now only contains the data relating to females, which have a minimum spend of 3.23 and a maximum spend of 998.76. The average is calculated at just under 520. The stream that's evaluated to false, on the other hand, is populated with M in the gender column, and this dataset has a minimum value of 2.6 and a maximum value of 998.52. The male average expenses come in lower than female expenses, with a value of 486.9. So already we can start to paint a picture as to the differences in spending of females and males with respect to this dataset. Now so far we've covered a very simple example where we use the basic filter to compare the gender column to the letter F. If there's a match, it's true. If there's not a match, it's false. But let's now copy and paste our first workflow and create another filter condition, this time on numeric values. So if we change the basic filter field to be dining out expenses, which we know is a numeric field, you can see we're presented with a slightly different list of comparison operators. So we can create conditions using the equal to, not equal to, less than or equal to, greater than or equal to, is null and is not null. Now these comparison operators will come up throughout the course, and I will also include some additional material on what they each mean if you have never come across them before. But for the purposes of showing how the filter tool works, we'll use the greater than symbol, which is denoted by the right-angled bracket. Now in the third box, we can stipulate what we want the dining out expenses to be greater than in order for the rows in the dataset to evaluate to true. So if I put 800 as an example, what Alteryx will do is once again search through the dining out expenses column, and where the row's value is greater than 800, it will be flagged as true. And if it's not greater than 800, i.e. 800 or less, then it will be flagged as false and will feed the F stream of the filter output anchors. So when we run this workflow, you can see that the browse tool of the true stream now shows us a mixture of male and female genders, but all of the expenses are greater than 800, which you can see is the case based on the minimum value in the profile view. And if we select the false stream browse tool, the maximum value observed in this dataset is 792.18, which is clearly less than 800. Now so far, we have just observed how to write basic filter conditions to obtain true and false datasets. But let's now move on to create slightly more granular Boolean expressions. So we'll once again copy and paste the workflow, and in this third example, we're going to switch across and select the custom filter. And the first thing you will notice is that the basic filter has been translated into a custom filter, i.e. this is what you would have had to have written in the custom filter in order to replicate the basic filter. Now just on a side note, you will find the formula options in other configuration panes as well, which allows you to seek for specific formulas or functions that may be useful to you. And as you can see, they're categorized for easy navigation. So you can see conditional statement formulas as well as the different operators within Alteryx. You can also see many other options such as math functions, string functions, and so on. Now underneath this, you have a way of identifying existing columns and constants if you ever need a reminder as to what they are. But if you know your datasets well, then this will be used less frequently. Finally, you can assess recent expressions or saved expressions, which saves you from having to write the same expression out multiple times. And you also have the ability to save your expressions as per the final option. Now in this example, we're going to create a multi-conditional statement. So as well as checking to see whether the rows have dining expenses greater than 800, we also want to ensure that the true stream only brings through gender of female. So we can type an AND keyword, which simply means we want the first condition and the second condition to evaluate to true in order for the data to feed through to the true stream. Now after the AND keyword, we're going to start typing gender. And as you can see, we get a lot of predictive options that Alteryx brings to our attention, which can also help navigate formulas if you ever forget what they are. In this case, if I type GEN, you can see that Alteryx recognises that we're wanting to search for the field gender, and when it appears we can press return accordingly. Now in a similar way to the basic filter, we can now state that we want the gender to equal F. So now only those rows of data that are greater than 800 in terms of dining expenses and where the gender is F will the data feed through to the T anchor. When I run this and then observe the top browse tool, we do indeed get a result back which contains all female data and only those records that are greater than 800. When we look at the second browse tool, you can see this dataset will comprise of all male data and female data where the dining expenses were less than or equal to 800. Now I could have changed the word AND for the word OR, and this would have brought back a slightly different result, as only one of the conditions would need to have evaluated to true in order for the row to be sent to the T stream. Okay, so hopefully this was useful to see how you could include multiple conditions to create some further granularity in your filtering criteria. But I just want to end on one other use case to showcase how functions can also be used to generate conditional statements. So I'll once again copy and paste the workflow and then select the filter tool. And this time in the configuration pane, we're going to write a condition that looks for first names that start with the letter A. If they do, we want them to evaluate to true. If they start with anything other than an A, we want them to evaluate to false. Now we don't want to have to scroll through the entire dataset and look for names starting with A and include them manually in our conditional statement. That's far too time consuming and not very sustainable if new records come into the dataset at a later point. So what we can do is utilize a string function to do some checking for us. So if I start by typing out start, you can see that Alteryx predicts that we're looking for a function known as starts with. Now you could have found this function by looking in the string functions list, but here you're able to see that the starts with function is expecting a couple of inputs. Firstly, it's asking us for the string that we are looking to observe. So in our case, we want this to be the first name field. Next, we have to provide it with a target, which simply means what you are looking to check that the string starts with. And thirdly, we can see that the function itself is defaulted to be case insensitive, i.e. the case insensitivity is set to true, and we will see a quick example as to how we can change this shortly. So as mentioned, the string we will use will be the first name field, and the target will be the letter A, which we will put in single quotes to represent a string value. Now seeing as we're not putting in the third argument to stipulate whether we want this function to be case sensitive, it will by default be case insensitive, meaning it will search for uppercase A's as well as lowercase a's in the first name field. When we run the workflow and look at the data that has fed the true stream, we can see that we get a result set that only has first names beginning with the letter A, and there are 26 in total. The rest of the dataset would have fed into the false stream. Now if I go back into the configuration window and put in a third argument to the case insensitivity parameter, I can do this by putting a 0, which can be translated to mean false, i.e. case insensitivity is now false, which means that the function is now case sensitive, and hence will look for lowercase a's at the start of the first name. When we run the workflow, we get 0 results coming back in our dataset, as they all begin with uppercase a's. Now once again, you can chain as many conditional statements as you'd like to create granular criteria, so we could add a second conditional statement which checks for dining expenses greater than 300. When we run this, our true stream reduces from 26 records down to 18 records, and we now have first names beginning with A which have expenses over 300, and this dataset can now be fed onto subsequent tools. So to summarise, if you want to split your data into two separate work streams, you're able to use the filter tool to achieve this. The filter tool can be based on a basic filter, or you can create custom filters which allows you to include multiple conditional statements using various functions to create Boolean expressions that either evaluate to true or false. Rows of data that meet the conditions feed to the true stream, whilst the remaining rows of data will feed to the false stream. In this video, we'll be taking a look at arguably one of the most popular tools in Alteryx, known as the formula tool. So what is the formula tool used for? Now, we are all likely to have experienced data that is fed from upstream systems or a particular data source that has some form of data quality issue, and it requires a bit of cleansing before it is in a state to perform some form of visualization or calculation on it. The formula tool is great at addressing data quality issues that may exist in particular fields within your dataset, but better still, the formula tool allows you to create fields within the dataset that may otherwise be omitted or simply not available. Now, more strategically speaking, correcting data quality issues upstream would be of preference, as it would mean we would consume the data without having to cleanse it. However, in reality, getting upstream changes or changes to source files may take too much time, it may be too costly, or just may not get prioritized against more important items within the system owner's book of work, and this is understandable. So Alteryx enables us to implement semi-strategic fixes to data quality issues that may otherwise be expensive to address. Now, the formula tool can leverage many different functions, and we will explore how we can locate each of them shortly. But this video will not address specific functions. The main goal of this video is to understand what the formula tool can be used for, and you should look to cover the array of functions available in your own time. So let's first drag an input tool onto the canvas and connect to a new dataset called City Populations, which gives us some very basic information. We have state name, city name, and a value representing the population for each city. We will then drag a formula tool so that the input's output anchor joins the input anchor of the formula tool. Okay, so the first thing we're going to do is simply add another column onto our dataset, which tells us the data source name. This way, if we use it in subsequent parts of our workflow, we know exactly where the data has come from, acting as a good audit trail. Now, in the configuration window, we have a simple box in which we can incorporate specific logic. Now, the logic we include can leverage many different functions, just like functions in Excel, functions in Python, or the functions in Tableau when creating calculated fields. So if I click on the little FX button here, we will be able to see different functions and the respective parameters we have available. So if we wanted to create conditional statements, which we will do shortly, we can click on conditional and see what functions are available. If we wanted to see what functions we can perform on strings, we can click on strings and we can then use these functions accordingly. So we'll use starts with as an example later on. So the first thing we said we were going to do was add a new column stating the dataset name. So we can click on the drop down and select add column. And then we can give the column a name. So in this example, we will call the new column data source. Seeing as this column will simply hold a string value, i.e. text, we will change the data type to a v string. Now, seeing as this value will be constant, we could choose a string data type, as this holds string values which are fixed in length. But for this example, we'll stick to v string, which allows us to include variable length Latin 1 characters, which for our purpose is absolutely sufficient. We will also change the size to be 20, i.e. the field will contain a maximum of 20 characters. Now we will enter into the white box what we want to be evaluated for each line. So in this example, we will simply want every line in our dataset to be given a string called city populations. So let's type city populations, and this will then be applied to each line. Now you will hear me say each line often, as it's important to recognize that the formulas or logic you include are applied to each line in the incoming dataset. So we'll add a browse tool to our formula tool, and then we can run the workflow. Now the logic has been applied to close to 30,000 lines in a fraction of a second, and we now have a new column in our output called data source, which states city populations for each row. Great. Now the next thing we want to do is update a data quality issue using some logic. Now this data quality issue has been made up by me for illustrative purposes, but let's assume that the city called Append does not have a population of 192, but in fact has a population of 1,000 people. Well, we can add multiple formulas to a single formula tool by clicking on the little plus button, and the formula box is replicated. So in this example, seeing as we want to update the population column, we will select population from the drop-down list. Now the logic will be simple. We will include a conditional statement, and our conditional statement will state if city, and notice here that when I start typing a column name from the incoming dataset, Alteryx will provide recommendations as to what you may be looking for. So if city equals, and then we will have this set as the string Append. Then we want to provide the population with a value of 1,000. Else all other cities will simply keep their original population value. So we can type else population. We can then end the if statement by typing end if. When we now rerun our workflow, you will notice that we still get our newly added column called data source, but this time we have a result set that has updated the population of Append to be 1,000 rather than the original value of 192. So this newly updated dataset can then feed its way through other tools for further transformation and analysis. Okay, so let's keep going through some examples. Next, we will create a population rating column, which will categorize our populations into low, medium, and high. So for this, we will add a new column called population rating, and we will set the data type to be vstring with a size of 10. Our logic will be conditional, and we will state if population is less than 1,000, then we want the string returned to be low for that row in question. Else if the population is less than 10,000, then we want the rating to be medium. For any row that does not meet the first two criteria, we want the value returned to be high, so we can type else high. We can then end the conditional statement by typing end if. Before I run this workflow, I want to point your attention to what Appen's result ends up being. What do you think it will bring back as a result? Low, medium, or high? Well, let's find out. When I run the workflow, you can see we obtain a new column called population rating, and each row is provided with a value as per our conditional statement. Now, in the case of Append, we obtained the value medium. This is because the population column has been updated before the application of the population rating column. So the order in which you provide multiple formulas in a single formula tool will influence the output, and I will showcase an example of what happens when you change the order shortly. So we're now at the point where we've created two new columns and corrected an existing column. Let's observe another function by creating a new column in the dataset. This time, we will assume that a fictional company will assess new regions to set up a new branch and will carry out the investigations in two phases. Phase 1 will be those cities that start with A and have a low population rating, and the rest will be Phase 2. So let's add another column and label this column Observation Rating. This column will be a vstring data type with a size of 20. We will write a conditional statement by firstly stating that if population rating equals low, which has been set from the prior formula, and, so here we are introducing multiple statements, and now here we need to check that the city starts with A. So we can go back into our function list and select the string function that performs a start with operation. The first parameter we need to enter is the field in which we are checking. So in this example, it's city. And then the second parameter is the value we are checking for. So in this example, we are checking for the letter A. If a row in the incoming dataset meets this criteria, then we will set this as phase 1. Else all other records will be tagged with a string called phase 2. When we rerun the workflow, as expected, we get another column called observation phase, which splits our close to 30,000 rows into phase 1 and phase 2. Great. So let's finish with a couple of examples where we use numeric values as opposed to strings. Firstly, we will add another column which assigns a forecast growth percentage to each row. And this will once again be conditional in nature. So we will call the column population forecast percentage, and here we will simply state that if population is less than 10,000, then we will state the growth forecast to be 10%, i.e. 0.1. Else, if the population is less than 30,000, then the forecast growth will be 15%, so 0.15. Else all other rows will be applied with 20% forecast, so 0.2. Rerunning our workflow will give us a new population forecast percentage column. Now we can use this column to create a new column which performs a calculation on specific values. So let's create our final column called forecast population. And here we will simply multiply the population field by 1 plus the population forecast percentage. And to anticipate the formatted output, seeing as we can't have a fraction of a person, we will floor the result to the nearest integer, i.e. round down to the nearest whole number. So here we're using a new function and performing calculations for each row, taking values from either existing fields or fields that have been created from the formula tool. Now when we run the workflow, we get a final column which forecasts the new population. So here we've covered numerous examples as to how we can build up a more enriched dataset whilst also covering a small data quality correction example. Now, as mentioned earlier, the order in which you create fields or change existing fields is important. In the examples we've covered, we have first changed a data quality issue within the population field, i.e. we've changed the Append population to be 1000. Seeing as the population field is then used in the population rating logic, we then show a population rating of medium. However, I'm able to move the order in which the columns are calculated. So if I were to move the population data quality change to the bottom of all other formulas by clicking on the left-hand side of the field on the 4 little lines and then dragging the field to the bottom, and then rerun the workflow, you are able to see that the population rating and the observation phase has already been calculated to be low and phase 1 from the original value of 192. Therefore, always try to get in the habit of correcting data first. If you have a formula tool that utilizes a field that has erroneous data and other fields are dependent on that field in some form of logic, make sure the data is corrected first. If you don't, you may get erroneous results which impact decision making. Once again, whatever your formula tool outputs can then be fed into subsequent tools in your workflow to really control the way you want to transform your data. In this video, we'll take a look at a tool known as the sample tool. Now, the sample tool allows us to perform 6 types of data sampling, and we'll be seeing each of them in action in this video. So let's first of all drag in an input tool onto the canvas. And for this example, we'll switch things up a bit and connect to the US President's dataset that I've also included in the resources section. What we will then do is connect a sample tool to the output of the input tool. Okay, so the first thing we can see is, as expected, the sample tool configuration window, in which we have to set a few settings to influence the output we want to observe. So let's start by selecting the sample type called first n rows. As you've probably guessed, The first n rows will obtain a predefined number of rows from your dataset in the order in which the data feeds through from the input tool. So let's set n equal to 5 in this example. If we add a browse tool to the output of the sample tool and then run the workflow, you can see that we get the first 5 records that you can see from the output anchor of the input tool. Now, the order the dataset comes in from the input tool can obviously be changed by using the sort tool, for example, for which we can then sample the first n rows of a newly ordered dataset if we have the need. So layering up different tools can lead to different ways of observing data. The next sample type is known as the last n rows, and this performs a very similar operation. The last n rows will collect the last amount of rows that you specify from the input data. So if I change 5 to 3, you can see when I rerun the workflow that we get the final 3 records from the US President's dataset, which refer to Bill Clinton, George W. Bush, and Barack Obama. Now, there is an optional configuration we're able to define, which is the group by column. I'm going to introduce this now as I feel it's easier to digest and observe the resulting output. So if we were to group by party in this instance and also switch the sample type back to first n rows, what the sample tool will do is first group by the party name, i.e. it will observe all the unique values that exist within the party column, and it will then return the first n rows, in this instance 3 records for each party, in the order they come in from the input data tool. So if we take a look in the raw dataset and predict what records we will see, Andrew Jackson, Martin Van Buren, and James K. Polk are the first 3 records for the Democratic Party. I would then expect to see Thomas Jefferson, James Madison, and James Monroe for the Democratic Republican Party. Now, where there are not 3 records for a given party, for example, Federalist, which only appears once, we will only observe one name, i.e. John Adams in this example. So if we now run the workflow and observe the output, we do indeed get 3 records back for each party, where there are 3, and they appear in the order they come through in the dataset. So group by can be used with any sampling tool to bring back a sample across a grouped dataset. Okay, so moving on to observe the other sample types, we have the skip first rows. This type will ignore the first n rows that you select in the output. So if I ungroup everything and set this equal to 10, when we rerun the workflow, you will see in the output that the first 10 rows have been ignored and the index starts at 11. If I then group by the party field, the first 10 records for each party will be ignored, and because we only have the Republican and Democratic parties with more than 10 representatives in the dataset, we only get presidents 11 onwards for each party respectively. So skip first n rows will ignore the amount of records you've stipulated in the output. Okay, so moving on, selecting one of every n rows will simply select a row with equal increments. So not grouping and setting this to 10 will mean we get a result which shows index 1, then 11, then 21, and so on in our output. If I had grouped this by party, we would get 1 every 10 rows for each party. So if I rerun the workflow, you can see that we therefore only show a couple of Democratic and Republican Party presidents and then 1 for every other party, as they do not have 10 presidents to iterate through. Okay, so moving on to the 1 in n chance to include each row. This is where we can obtain an output that is predicated on chance rather than stipulating a more controlled sample. So if we set this equal to 10, the rows in our dataset will be randomly chosen at a rate of 1 in 10. In other words, there is a 10% chance of the row being selected. So the key thing to note here is that as this is predicated on a probability stipulated by the user, you will not end up with the same result each time. In fact, you will not consistently end up with the same amount of records. So if I run the workflow a few times, you will see the amount of records that I get back changes on occasions with different names populated. So this is a nice way of being able to randomize your sample. And finally, we have the first n% of rows, which returns a percentage of rows back from the input data. So if we left this as 10, we will obtain the first 10% of rows, which on a dataset size of 44 will result in a result set of 4 records, in the order they come in from the input dataset. So hopefully this has been useful in seeing multiple sample types we have available. Using in conjunction with other tools can allow for specific parts of your datasets to feed through to subsequent stages of your workflows. So sampling is obviously very good when you're working with large datasets and want to restrict the amount of records that feed through, as well as being very useful when testing outputs across subsets of your data. In this video, we'll be taking a look at the sort tool. Hopefully you've come across similar functionality in your data analytics journey to date. For example, you may have sorted data in spreadsheet software like Excel or Google Sheets. Now you can sort data on both string fields, i.e. you can order words in alphabetical order from A to Z or reverse alphabetical order from Z to A. Or you can sort numbers, either from lowest to highest, i.e. in ascending order, or from highest to lowest, which is descending order. Now, in order to illustrate how it works, we will look at a few examples using the restaurant sales dataset. So I will drag in an input tool and connect to the restaurant sales dataset accordingly. This dataset contains information on a restaurant's sales and shows the check number, the waiter that served the table, the amount the table spent, and the number of people who were seated at the table. So let's now drag a sort tool onto the canvas and connect the output of the input data tool to the input of the sort tool. When we do this, you will see a simple configuration window appear on the left-hand side. The first column is asking us to select a column in which we would like the values to be sorted. So if I click on the first drop-down, you can see we are presented with the 4 column names that we are able to sort by. So for the first example, let's sort the total bill column, which is a number representing the bill total for each check. The second column simply asks us to select either ascending order or descending order. Ascending will go from lowest to highest, or in the case of string data types, it will order from A to Z. Descending will go from highest to lowest, or Z to A. So if we were to select descending, and then add a browse tool and run the workflow to observe our first result, you can see that our dataset in the results window is ordered from highest to lowest, and the waiter Rodrigo served a table of 2 who spent 156.95, which was check number 180, and this was the highest bill total. As we scroll down, the total bills decrease. Okay, so let's go back to the sort tool and go across to the configuration window where we'll carry out another example. Let's select the number of persons column and sort in ascending order. When we run the workflow, you can see that we have all the 2s at the top, which is representing the lowest value that this column contains. And if we scroll down, we can see the next value to appear is 3, then 4, 5, and so on. So this is a very simple example of sorting by an individual column. Now Alteryx allows us to sort by multiple columns, and this is done by simply selecting another column to sort by in the configuration window. Now the important thing to remember here is that columns are sorted independently and in order that they appear in the configuration window. So for example, if I were to add a second column to sort by, so let's add total bill and sort this in descending order. What this will do is first sort the number of persons column. It will then sort the total bill values while still maintaining the sort order of the first column. So let's run this workflow to observe the output. So here you can see that we have a data set with all the tables that seated 2 people at the top, But this time, when we look across into the total bill column, we can see that the total bills are ordered from highest to lowest. And if I scroll down to where tables start seating 3 people, you can see that Ruby served the table with the highest bill for the tables that seated 3, with a total bill of 154.95. Now, as mentioned, the order that the columns appear in the configuration window is important, as they are taken in turn, and this ordering can be changed by using the up and down arrows on the right-hand side. So if I select the total bill column so the row is highlighted, and I were to press the up arrow, this will move the total bill column 1 level higher in the sorting order, which in this case is to the top of the sort. Okay, so let's move on to another example and show some more features. I'm just going to copy and paste the first workflow underneath itself, and then go into the configuration window of the second workflow. So you may have noticed a little negative symbol underneath the arrows. If you wanted to remove a column from your sort consideration, then you can select the column you would like to remove. In this case, I will select the number of persons column, and then hit the remove symbol accordingly. Now in the next example, I will change the total bill column to be the waiter column, which we know represents the name of the waiter that served the table. Now if I change the order to ascending and run the workflow, what we will see is the waiter column sorted in alphabetical order, as it is a column that contains string values. So Alex appears first in this list, followed by Amanda, followed by Amit, and so on. Now one thing I would like to bring up is that string fields do not necessarily have to be stored using English, or English of the United States by default. If we click on the Use Dictionary order, you are able to change the dictionary which is taken into account when sorting the values. And the list is vast, so take this into account when you're attempting to get string values sorted in a particular order, which may be based on a different dictionary of characters. So to summarize, you can select columns that you want to sort using the column name. Once defined, you can decide whether you want to see the sort in ascending order or descending order. You are able to sort by multiple columns, and the sorting will be done in reference to the first column in the list, followed by the second, and so on. The sort tool is also very useful when used in conjunction with other tools, and we will see an example of this when we cover the unique tool. In this video, we'll be taking a look at what is known as the unique tool, and conceptually it's very straightforward. What the unique tool allows us to obtain is a result set that is considered unique based on the field or fields you want to observe, and the unique values will feed into the U output stream, which simply stands for unique. If there are duplicate rows of data, they will feed into the D stream, which stands for duplicate. Now, in order to illustrate how it works, we'll look at a few examples using the restaurant sales dataset. So I'll drag in an input tool onto the canvas and connect to the restaurant sales dataset accordingly. Now, for the purposes of this illustration, I'm actually going to bring in a sort tool, which we observed in the last video, and I'm going to sort the waiter column in ascending order, i.e. the waiter column will be ordered in alphabetical order. And we'll also sort the total bill column in descending order, i.e. the amount will be sorted from highest to lowest. When we add a browse tool and run the workflow, you can see the resulting dataset in the results window. Okay, great, so with the dataset as per expectation feeding out of the output anchor of the sort tool, we can now remove the browse tool and replace this with a unique tool. So the sort tool output will connect to the unique tool input. When we click on the unique tool, you can see we are presented with a very simple configuration window on the left-hand side. We simply need to select columns to find unique values within. So to start, we'll simply click on Waiter. When we run the workflow and observe the unique stream's output, you can see that we are getting one row back for each name respectively. So we can see one row with Alex, followed by one row with Amanda, followed by Amit, and so on. Now the key thing to note here is that we are only looking in the waiter column for unique values. So we are only observing the name Alex once in this result set. And the respective columns of data in this result set, i.e. the total bill and the number of persons, is predicated on the first value observed. So in this example, we are getting a single row back for the waiter named Alex, and we can also see that we are getting a total bill of 153.86 for which he served 4 people. Now this is because we have sorted the total bill in descending order, and 153.86 was the first record that was observed which contained the waiter Alex. The second record also contained the waiter Alex, which is therefore considered a duplicate, despite having a different total bill of 152.63, and this record will feed the D stream. All of the other rows of data that have the name Alex in the waiter column have been fed into the D stream, or the duplicate stream. If we scroll down to Amanda, you can see that the first observed value was check 798 with a total bill of 151.03, and number of persons is 6. If we go back to the unique stream, you can see that this is indeed the record that is pulled through as the unique record for Amanda. Now just to make the point clear, if I change the sort tool so that the total bill is sorted in ascending order and rerun the workflow, you can see that we are now getting a different unique row for Alex, but we are still only getting one row with the name Alex in it. So the input into this unique tool is important in determining what is the unique record that is observed if you are not selecting all of the fields in the configuration window. Okay, so let's just quickly change this back to descending order and take a look at the duplicate stream. Here you can see that we have all of the other rows of data, so a lot more rows of data with the name Alex in the waiter column, because Alex had already been observed once, same with Amanda, and so on. In this next example, we will go back to the configuration window and we will also select the number of persons field. Now before I click run, give yourself a brief moment and pause this tutorial to think about what will happen here and what you might expect to see as the result. Okay, so because we have now selected 2 columns, what we are telling Alteryx is that when there is a row of data that has a unique combination of waiter and number of persons, then feed this row to the U stream. All other rows should feed the D stream. So when we run the workflow and observe the result, you can see that we're getting more rows back with the waiter name Alex, in fact 5 in total, and each of these rows has a different number of persons. So each row in this result set is unique based on the combination of waiter and number of persons. You will not see 2 rows of data which have the same waiter name and number of persons value. The remaining rows from this dataset will feed the D stream. If we now add the column total bill in our configuration window, what do you think will happen? Well, if we run the workflow, what you can see is that Alteryx is bringing back rows of data where the combination of all 3 columns is unique. Now, because the majority of the rows have a different total bill value, the majority of rows are feeding into the unique stream. However, if we click on the D output anchor, you can see we have 1 row of data that is appearing. Now this tells us that there is already a record in the unique stream with the combination of values Amit, 114.45 and 4 persons. So if we go across to the output anchor of the sort tool, which is feeding the unique tool input, and scroll down to Amit, you can see that there are indeed 2 rows of data where the combination of these 3 columns is identical. Hence the first observed record is feeding the unique stream and the second observed record is feeding the duplicate stream. So to summarize, you can use the unique tool to observe unique rows of data from your incoming dataset. The first observed row of data that contains a unique record based on the field or fields you select will feed the U stream, and any subsequent observation will feed the D stream. If you are not selecting all fields in the configuration window, you can use the sort tool in conjunction with the unique tool to get your records in a particular order that you may want to observe. Welcome to this new section where we will focus on a new category of tools that Alteryx offers, known as join tools. Now, join tools span multiple capabilities, but they all have one thing in common. They all, in some form or another, add data to data, meaning that we can take data from one dataset and combine it with another dataset to make one dataset.
Now we'll be exploring 4 fundamental join tools, which are used frequently in data transformation, and these are join, union, find and replace, and append fields. So let's get started. The first tool we're going to observe is the join tool. Now the join tool enables us to join 2 incoming datasets together in a very similar way to how you would join 2 tables in an SQL statement, if SQL is something you are familiar with. If you are not familiar, let me quickly outline what I mean. Now, data is usually stored with a concept of relation. For example, you may have a database that hosts data for a retail store. One table may pertain to customer information, which has items like customer ID, name, address, and telephone number. You may then have another table which shows sales, which has information like sales ID, customer ID, and purchase date. Now, despite this information residing in 2 different tables, we are able to obtain information pertaining to a specific customer and ascertain whether they have purchased anything by observing the customer ID column in the sales table, and then referencing the same customer ID in the customer table to bring back information such as their name and address. Now, we can join many different datasets together across disparate data sources. For example, we can join data that is stored in a database to data that is maintained in Excel or a CSV file. We can join data across different databases such as Oracle and a MySQL database. Wherever data resides, we are able to join it together providing there is a common element, otherwise known as a joining field, which we will explore shortly.
So we'll cover 4 common join types known as the inner join, left join, right join, and the full outer join. Now, the syntax required to construct these join types is very similar, but it's more important to understand the concept of each join and the result each join type will produce. So firstly, we have the inner join. The inner join will retrieve rows from both tables, providing there is a match between the joining fields. If there is no match between the tables, the rows of data from both tables will be omitted from the output. This is represented by the blue segment in the Venn diagram. So let's take an example of 2 tables. On the left we have a small employee table which consists of 10 employees, and we're provided with the emp ID, full name and hire date. In the table on the right we have information regarding each employee's salary. The fields available are emp ID, prior salary and current salary. Now, by performing an inner join on these tables, we will get back a result where we have matching emp IDs, as emp ID is the field we would use to link these 2 tables together. These joining fields are also known as keys, and we'll cover primary and foreign keys in more detail later in this section. So as you can see, as both tables have emp IDs 2, 4, 6, 8 and 10, these are the only values we obtain in our output once the join has been performed. This means we are now able to see what the prior and current salaries are for each employee alongside the full name and the hire date in one single table. Now, when we perform a left join, the result we obtain will take all information in the left table and it will be enriched with information from the right table if there is a match within the emp ID column. If there is not a match, then the columns from the right table will be populated with null values like so. So here you can see we have all data from the left table, and we now have information from the right table where there was a match in emp ID. Where there is not a match, the right table values have been populated with null. Now the right join is essentially the same as the left join. However, this time we have a result where all information from the right table will be present and will be enriched with information from the left table where there is a match in emp ID. Any rows that do not match will result in values from the left table being populated with null. So the result will look something like this, where you can see all data from the right table, and where there is not a match, the values in the left table columns are populated with null. And finally we have the full outer join. Now this result brings back all data from both tables, and where there is a match in value within the joining field, information from both tables will appear on a single row. Where there is not a match, information from the left table will appear alongside null values from the right table, and information from the right table will appear alongside nulls from the left table. So hopefully that provides some useful insight, or in some cases a refresher, on join types. In the next video,
We will see practical applications of the join tool in Alteryx and cover the configuration options available. So let's get straight into observing how the join tool works in practice. Firstly, we will need two datasets that we're looking to perform a join on. Therefore, we will drag two input tools onto the canvas. The first input tool we will connect to a dataset called Tutorial Data, which contains information on individuals such as their name, birth date, gender, and email. The second input will be on a dataset called Tutorial Data Addresses, which contains information such as phone numbers, address information including city, state, and zip information. Now let's suppose that we have been asked to obtain the names of individuals who live in the state called Hertfordshire. Now for those who are familiar with UK geography, you'll be familiar that Hertfordshire is actually a county in the UK, but for the purposes of this dataset, it is classified as a state. So what options do we have when it comes to obtaining the names of individuals who live in Hertfordshire? Well, firstly, we could go into the Tutorial Data Addresses data and filter for Hertfordshire within the states column. This will then bring back a list of user IDs, which we could then note down and then look up in the tutorial dataset where the names reside. Now this is clearly far too manual and way too much effort, especially if we wanted to do this for 100 different states. As I'm sure you've figured out, we can connect these inputs to a join tool and then join these two tables together. So let's drag a join tool onto the canvas and we can then connect the tutorial data to the L anchor, which will therefore mean we are treating the tutorial data to be our left table. And we can then connect tutorial data addresses to the right input anchor, meaning this dataset will be regarded as the right table. If we then click on the join tool, we are able to observe the configuration window and the options available. Now there are two join options available. We can join by record position, or we can join by specific fields. Now the default option is join by specific fields, and I would personally always recommend using this option when performing join operations. As you will soon realise, we have a lot more control and can disregard the ordering of data in datasets, which gives us one less thing to worry about. Now as we're joining two tables together, we need to establish what field or fields we should use as the joining fields. Now in this example, you will notice that we have a field called User ID that is present in both tables. Now if you're new to the concept of joining data and would like to explore this in more detail, I would recommend joining me on my MySQL Bootcamp course, in which we go through fundamental join concepts through the lens of SQL, which makes for an easier time in conceptualizing joins in Alteryx. So let's go ahead and stipulate that we want to use the user ID from the left table, and we want this to match the user ID in the right table. Now what this will result in is the following. Where there is a match in user ID, for example, let's say that user ID 100 is present in both tables, we will obtain a new output table which contains the columns from both the left and the right table, and the rows which contain user ID 100 will line up on one row. All records that have matches on user ID will form part of the J output anchor, which is denoted by this little icon here. This is the same diagram as the inner join diagram I shared in the prior video. Now where user ID does not match in either table, i.e. where there is a user ID in the left table that is not in the right table, or vice versa, the results will feed into either the L output anchor or the R output anchor accordingly. The L output anchor represents all the data from the left table that did not have a corresponding match in the right table, and the R output anchor represents all the data from the right table that did not have a corresponding match in the left table. The section below provides us the ability to select the columns that we want to feature in the final output from the left and right tables, as well as the ability to change column headers, change data types, change the size of the respective field, as well as provide short descriptions for the column in question. Essentially, it's a select tool embedded in the join tool configuration. Very useful indeed. So for this example, let's suppose we want all the columns from both tables, and the user ID from the right table will be prefixed with the word right to distinguish itself from the user ID in the left table. When we run the workflow, you can see that when I click on the J output anchor, which resides in the middle of the 3 output anchors, we get an enriched dataset with columns from both tables. The first thing to point out is that this dataset is where user IDs match. So as you can see, as you assess each line, the user IDs from the left table are the same as the user IDs in the right table for each given row. Therefore, we can now state that Aisha van Hengel lives in the city of Zutphen, and Sebastian Madsen lives in Lintrup, and so on. Now, if I click on the left output anchor and the right output anchor, you will notice that there is no data present. This is because every line in the tutorial data had a match with data in the addresses data. So let's change this slightly so you can see an example of how unmatched records get handled. So we will first copy and paste the small workflow we've just created, but this time we will add a filter tool in between the addresses dataset and the input to the right table input anchor of the join tool. We will now filter for only those records that have a user ID less than 8,000. In other words, we are removing user IDs from the right table that are 8,000 or greater, to make sure we get some line items that don't match. We will also deselect a few columns from both the left table and the right tables to make our final dataset smaller. When I rerun this workflow, what you will notice is that the J output anchor once again contains the rows that match. However, this time, the L output anchor contains user IDs which are 8,000 or greater. This is because they do not exist in our right table input, seeing as we filtered them out of the right table, and hence were regarded as unmatched and fed into the L output anchor. The R output still has no data in it, because every item was matched with data in the left table. Now at the start, I asked what options do we have when it comes to obtaining the names of individuals who live in Hertfordshire. Well, seeing as we've now joined the datasets together, what I can do is add a filter to the J output anchor of the first workflow and have the condition to be where state equals Hertfordshire. When I run the workflow again, we'll be able to see all of the names of the individuals who live in Hertfordshire, with some towns and cities which are very familiar to me. So try the join tool on some of your own datasets. You simply need 2 datasets which have a joining field that links them together. Now in the prior video, I mentioned the concept of left and right joins, as well as the full outer join. Now so far, strictly speaking, we have only obtained the output for an inner join, which is the J output anchor. But in order to get a complete left join result, a complete right join result, or a complete full outer join result, we need to use the join tool in conjunction with the union tool, which we will see in the next video. Let me finish by stating that, over time, technology has advanced. Data now exists in more forms and places than it ever has done before. And Alteryx is a fantastic option for being able to join disparate data sources together to come away with a consistent, enriched dataset that is ready for onward use, whether that be analytics or subsequent steps in your workflow. In this video, we'll be taking a look at another tool that joins data together, known as the union tool. So what does the union tool allow us to do? Well, in short, it allows us to stack 2 or more tables of information on top of each other. Now, unions can be configured in a couple of ways. So we can either union columns based on column names, i.e. if the column names are the same, then the data will be placed underneath the respective column names. Or you can union based on position, i.e. column 1 from table 2 will be placed underneath column 1 from table 1. Now a third option we have available is to manually configure the fields and choose which column from one table goes underneath columns from a different table. So first of all, for illustrative purposes, I have created two very basic text inputs which have 5 columns of information. We have ID, item, quantity, delivery date and table for the first table, and we have the same in the second table, but table 2 has quantity and the delivery date columns switched around in terms of order. Let's now drag a union tool onto the canvas so we can see how it operates. The first thing you may notice is that the union tool has an input anchor that is slightly different to ones we've seen previously. The 2 little angle brackets indicate that it accepts multiple inputs. So you can union 2 or more tables together by simply dragging the output of other tools, in this case 2 text input tools, to the same input anchor of the union tool. If we click on the union tool and then go across to the configuration window, you will see the first menu we get are the union options. Now the first example we're going to see is the default option, which is auto config by name. This means Alteryx will look for columns with the same name and align them accordingly. Underneath this menu, you will see we have a properties section, which asks us how we want to handle any exceptions. For example, if fields have different names or one table has more columns than the other, what should we do? Well, you can proceed in a few ways. If fields differ, you can have Alteryx throw an error which then stops any further processing of records. This would mean that a user would need to correct any inputs before continuing. But this is not always what we want, as there may be some known differences and we don't want the processing to stop. So Alteryx allows us to continue processing records and either displays a warning message to the user, which is good for feedback and establishing what the differences are, or you can have it so that it ignores any differences and simply continues trying to union the datasets together. For the examples to follow, we will continue processing records despite any differences in fields, and we'll get Alteryx to provide us a warning message if this occurs. The second option within the properties section is where we stipulate how we want the output to be handled if differences arise between input datasets. So firstly, we can get Alteryx to output all fields, and if a column exists in one table but not the other, null values will be used in place of where values were non-existent. The second option we have is to output a common subset of fields. This output includes only the columns that each input has in common, and therefore if a column exists in one table but not the other, the column will not feature in the final output. For our examples, we will have this set to output all fields. Okay, and the final thing we need to acknowledge is that each data input is given a reference. So table 1 is given the label #1, and table 2 is given the label #2, as can be seen on the connection lines shown here. This is based on the order you drag the inputs into the union's input anchor. So seeing as we drag this text input in first, it is assigned connection 1. In the bottom left-hand side of the configuration window, you can set the output order, i.e. which table goes above and which table goes below. Let's leave it as input 1 on top and input 2 second. When we add a browse tool to the union tool and then run the workflow, you will see we get a combined output. You will notice that despite the ordering of columns being slightly different in the two tables, Alteryx has placed the columns underneath the right column headers, and we now have one dataset that can be used in subsequent parts of the workflow. So when you have column headers that are the same in two tables, for which the respective data relates to each other, auto config by name is definitely the option to go for. Let's now take a look at the union option, auto config by position. For this example, I will simply copy and paste the first workflow, and then change the option accordingly. As the name suggests, this option will take the order of columns in Table 1 and align them with the order of columns from Table 2. Now, seeing as we have different column orders, let's observe what happens. When I rerun the workflow and observe the output, you can see that the delivery date in Table 2 is placed underneath the quantity column from Table 1, and the quantity column of Table 2 is placed under the delivery date column. No surprise here, as we have configured by the field's position. So you would really only want to use this option if the dataset's column headers are ordered the same, but the column headers are labelled slightly differently. And for completeness, I quickly want to show you the Manually Configure Fields option. Now, this option will give us the ability to move columns from Table 2 underneath specific columns from Table 1. So let me copy and paste the prior workflow and change the option to Manually Configure Fields. Alteryx in this example has actually been able to assume that we want columns with the same headers to be above each other. But if I were to move the fields around manually by using the left and right arrows, and then rerun the workflow, we get an output as per our manually configured position. So we've now covered 3 union options, all achieving the result of stacking one or more datasets on top of other datasets. Now, in the last video, we explored the join tool, and we have also looked at the concept of left joins, right joins, and full outer joins. Now, if you look at the diagrams I shared previously, you can see that the left join is represented by taking all the data from the left table, and where there is a match with the right table, the dataset will be enriched. However, the left anchor of the join tool is represented by this Venn diagram, which looks slightly different. Therefore, in order to replicate a left join in Alteryx, we actually need to union the L output anchor and the J output anchor so that the resulting Venn diagram is the same. So let's do this for the previous example we visited in the last video. If I drag a union tool after the join tool, and then drag the L output anchor and the J output anchor into the input anchor of the union tool, this will perform a left join, where all values from the left table will be present, and where there is not a match, the columns from the right table will be populated with null. So performing left joins, right joins, or full outer joins requires the combination of the join tool and the union tool to get the expected result. This is a very powerful combination of tools that allows us to join disparate datasets together and is used frequently when working with datasets from different sources. In this video, we'll take a look at a join tool known as the Find and Replace tool. The best way to think about the Find and Replace tool is to picture a very similar operation to a VLOOKUP in Excel. The Find and Replace tool is obviously configured differently to a VLOOKUP and actually has a couple of additional benefits we can take advantage of. So let's take a look at what they are. Firstly, as always, we will need some data. So what I have here are 3 tables. The first table is our main dataset, which has some information on customers and the amount they owe. We then have 2 tables which can be thought of as mapping tables. They are tables which will help enrich our main dataset with new information in the same way a VLOOKUP would do. So first things first, let's drag a Find and Replace tool onto the canvas and observe the input anchors that we need to connect to. You will notice that we are presented with an F input and an R input anchor. The F input can be regarded as the data source that contains the main dataset, in which you are trying to look up in order to either replace or to act as a key in a mapping to bring back new columns. The R input anchor will contain the source data that contains the information you are looking to use as the replacement data, or the value you're trying to append to the main dataset. So let's drag our main dataset to the F anchor and the short to long mapping table to the R anchor. If we observe the short to long mapping table, what you can see is that we have a column that is labelled short, which is just an abbreviated way of writing the long version of the word. Now the main dataset actually has this short abbreviated version in the customer column. So our first goal is to replace the short abbreviated text with the full long word. So the first configuration option we need to select is what we are trying to find and whereabouts we expect to find it. So we can select beginning of field, which will look for a string or substring that starts from the beginning of the text. We have any part of field, which means the substring we are looking for could appear at any point of the string. And finally, we have the entire field, which means the entire field will be considered in the search. For this example, seeing as our abbreviated text can appear at any part of the string, we will select any part of field. Now just to the right of this selection, we need to select the Find Within field. So this pertains to the field in the main dataset we are looking within, very similar to the lookup value in an Excel VLOOKUP. So we will select Customer in this instance, as it's the customer field that has the short abbreviated wording in some instances. We can then select what we are trying to find within this field. This selection comes from the R input anchor, and seeing as we want to find the short abbreviation, we need to enter the column short in this example. Now the last thing we need to state here is what we are looking to replace the value with. So seeing as we want to replace all references to the abbreviated word with the long word, we can select the Replace Found Text with Value option and then stipulate that we want it to be replaced with the long column's wording. Now the AND symbol and other abbreviated text may appear more than once in a given field, so we'll also select the Replace Multiple Found Items so we capture these. When we then run the workflow, you can see that wherever there is reference to the short column in the main dataset, we get it replaced with the long word. So ampersand becomes the word and co becomes the word company. Now let's look even closer. Notice here that at the bottom of the raw dataset we have a customer called Colorado Textile and Varnish, as well as Colorado Depth of the Treasury. Now in the final result, we have actually replaced the first two letters CO with the word company because we're looking up any part of the field and replacing accordingly. Therefore, to address this, we need to actually specify that we want the match to occur on the whole word only, irrespective of where that word sits in the string. So if we select the option Match Whole Word Only and then rerun the workflow, you can now see the bottom two records are being treated in line with expectation, and Colorado remains as Colorado. Okay, great. So I now want to show you how you can generate a new column with values from a mapping table in a very similar way to how a VLOOKUP works. So far, we've seen how to use a mapping table to find a specific string and replace it with a new value. So in this second example, I have a second mapping table which shows us whether the customer in question is related to the government or not. So if a customer has either of the words treasury, revenue, or of transport within their name, they are government related, and we need to tag these rows with a Y. So here, what we can do is connect the datasets to a find and replace tool, and once again, we're going to search any part of the field for the three words. We will look within the customer column in the main dataset, and we will find the value from our mapping table which resides in the column called department. Now our incoming dataset is actually in all capitals, whereas the department column is in lowercase, so we'll need to select case insensitive find to ensure we get a match. So irrespective of whether the values are in upper or lowercase, we will get a match if the letters are the same. Now because we want to append a new field and not simply replace, we are this time going to select the Append Fields to Record option, and this is where we now choose what field to append if there is a successful match, based on the above configuration. So here, we know we want to bring back the indicator which resides in the column called gov_flag. If we now run the workflow and observe the final output, you can see that our main dataset is returned, but this time with a new column called gov_flag, which has a Y that appears in 4 rows. These rows all have something in common. They all contain a word which existed in our lookup. So we have revenue, revenue, of transport, and treasury. So a very similar result to how we would expect a VLOOKUP to work. Great, so 2 common use cases for you to digest. Now the final point I want to mention is that the outputs of the Find Replace tool will always have the same length of string as the string that was inputted. So if the replacement tool is actually resulting in the string becoming a longer representation than the original dataset, then you may find that the output is truncated. In order to avoid this nuance, you can use a select tool and extend the size of the field so that the additional characters added through the replace tool are included accordingly and are not truncated. So keep this in mind. So hopefully this helps in understanding what the Find and Replace tool can be used for. Don't let the name confuse you here, as you can not only use the tool to find and replace values in a specific column, but you can look up values in a specific table and bring back new columns by appending it to your result set. Practice it on a few of your own use cases to make sure you understand how it operates in more detail. The final tool from the suite of join tools we will look at is known as the Append Fields tool. Now this tool will enable us to append fields from a source input to every record in a target input. So each record of the target input will be duplicated for every record in the source input. Now this will become clear when we run through some examples. So you will have noticed that I defined one input as source and one input as target. And this is exactly what the 2 input options are on the Append Fields tool. The T stands for target and the S stands for source. So let's put some data through the Append Fields tool to see it in action. First of all, we will simply use these 2 simple text inputs with some data representing department sale targets, and we have a second text input which has the seasons of the year. So we have spring, summer, autumn, and winter. Seeing as we know that each target input will be duplicated for every record in the source input, what are you expecting to see as the result? Well, let's drag an Append Fields tool onto the canvas and drag the first table of info into the target input anchor, and then the second input dataset into the source input anchor. If we add a browse tool and then run the workflow, you are able to see that we get 4 lines for each department sales target, with a different season for each row. This is because each row in the target stream has been duplicated for each record in the source stream. Now we can also switch these 2 inputs around, and we will obtain a very similar result, apart from the fact that now season is the target column. Now so far, we haven't run into any errors, despite our configuration at the bottom stating that an error will be incurred if too many records are being generated. But seeing as our source tables in both examples are less than 16 records, we are not running into any errors. If you do have appends that require more than 16 records from a source input, you will need to change the drop-down configuration, which is sometimes easy to miss at the bottom here. And this will need to be changed to warn on appends or allow all appends. So let's see this in action with a different dataset. In this next example, I will drag an input tool onto the canvas, and we will connect to the city population dataset which we have seen before. We will join this to the target stream of an Append Fields tool, and we will also connect our seasons data to the source. When we run this, we get the expected result, with 4 records generated for each record in the target dataset. Now, if I copy and paste this, and then switch the target and the source datasets around, you will notice that when we rerun the workflow, we run into an error stating that there were more than 16 records in the source. Now, this is true. In fact, we have close to 30,000 records in the source, but this is just a precautionary configuration that we can include. If we were sure that this was the operation we wanted to perform, we would have to change the warn/error on too many records being generated option to be either warn or allow all appends. If we change this to allow all appends and then rerun the workflow, we get the result that we expect. Now, it's worth noting that the Append Fields tool can sometimes lead to very large datasets if not used correctly. So if you have 2 small tables with 100 rows in each, the output will end up having 10,000 records, as the Append tool performs what's known as a Cartesian join. So you can appreciate that datasets can become very large when tables have large amounts of records. Now, the final thing to note is that the configuration window allows us to change data types, change column headers, size, and so on. So once again, it's essentially like having a select tool embedded within the Append Fields tool, which helps in redefining table structures for subsequent steps of the workflow. Welcome to this brand new section in which we focus on data transformation. So far we've explored inputting data, data cleansing and preparation, and joining data in numerous ways. This section is all about how we can transform our data. For example, how we can transform our data into new formats or aggregate our data to higher levels of aggregation. And we are starting nice and easy with a tool called Count Records. As the name suggests, the Count Records tool simply returns a count of the number of records passing through a data stream. So why would we want to perform this operation? Well, we may want to reference the count in some form of control or validation process. For example, maybe we are expecting our dataset to have at least 25,000 records in order to validate that the feed appears complete. So let's drag in an input tool and connect to our city population dataset. We can then drag in a Count Records tool and connect the input data to the input anchor of the Count Records tool. When we run our workflow, we get the count appear in the results window. Now we could feed this value into another tool for further processing, but this is as far as the Count Records tool goes. The tool itself does not require any configuration, as it will only ever perform a count on the entire number of records coming in from the input dataset. Now, it's worth mentioning that another tool that we will cover in this section, known as the Summarise tool, will also count records of an incoming dataset. However, in the event that the incoming dataset has 0 records, the Count Records tool will return 0 as the result, whereas the Summarise tool will not produce an output, which could subsequently lead to the workflow failing. So whenever you need to count records, maybe in some form of control check, then utilising the Count Records tool will be the safer option. In this video, we will discuss a transform tool known as the Transpose tool. Now, what the Transpose tool enables us to do is take values that exist in multiple columns and place them into 2 columns. Saying it out loud, I realise how confusing this could sound, so let me elaborate. Sometimes your data may be presented to you in what is known as a wide format. So you may have multiple columns that all relate to the same measure. For example, sales information for different regions. Now, if you wanted to conduct analysis on these sales values across the regions, you will have to use each column individually, which isn't very flexible when it comes to analytics. A way around this is by transposing data so that it complies with a long format, or what I like to call a tidy format, as it becomes much easier to perform analysis on data that has a single column representing a measure value. So in the example I'm about to take you through, we will be connecting to a dataset known as Pet Store Monthly Sales. If we look in the preview window for this dataset, this is exactly what I mean by wide format. You can see here that we have some information on the name of the store, address, city, state, and zip. And then we have a column representing the sales that occurred in January, the sales that occurred in February, and so on. So we have multiple columns that all pertain to sales information. If we wanted to pivot this information up or create a line chart of the sales over time, we would have some difficulty, as we have different measure values for each month. Wouldn't it be a lot nicer if all of these month columns were reduced into two columns? One column stating the month name and one column stating the value of sales for that month. Well, this is what the Transpose tool allows us to do. Now, one observation I have with this dataset is that we also have a column called Total. Now, if we summed up all months without the total, we would get the total. So I'm actually going to remove this column, as we do not need a separate column showing us this value. To do this, I can drag in a select tool and simply deselect the total column. I can then drag a transpose tool onto the canvas so that it consumes the output from the select tool. Now, in the transpose tool's configuration window, you will see that we have two main sections in which we can select columns. The first set of columns, known as the key columns, are the columns that we do not want to change. Columns checked in the key columns section will not change. Columns selected from the data columns section are those columns that we want to combine into two columns. This can be visualized conceptually by the following diagram. So key columns in dark blue remain the same, whereas data columns are combined into two columns, one labelled name and one labelled value. For the fields that are not selected in either of the selections, so not selected in the key columns or the data columns section, these fields will be removed from the output. So seeing as we want to keep the address fields as they are, we will select the first 5 columns from the key columns section in this example. Now by default, the remaining columns will be treated as data columns. So as you can see, the fields representing our sales figures are pre-selected. When we run the workflow, you can see that our dataset has changed into a long format. Each record in the dataset is a unique observation. You can see that we have 2 new columns on the end of our dataset, one labelled Name2 and one labelled Value. Name2 contains the name of the month, and Value contains the sales figures for each month respectively. Now note here that the column labelled Name2 is called Name2 because there is already a field in our dataset called Name, so Alteryx has provided a suffix of 2 to this column. If the dataset didn't have a name column already, the 2 would not be appended. Now with the format in this long format, we are now in a much better position to conduct time series analysis in numerous ways. Now we have not quite finished with our result, as I can see there is a tiny bit of red in the Name2 column implying there is some kind of issue. If I hover over the column name, we can see that 8.33% of the fields are not okay. And when we look down the column, this seems to be due to some values, like August for example, having trailing space. So let's clean this up. After the Transpose tool, we will add a Cleanse tool, and in the configuration window, we just have to make sure that the leading and trailing whitespace option is checked, which we can see it is. When we now run the workflow, our columns seem to be populated correctly, with no trailing spaces. One final change to make to this table will be the column headers for Name2 and Value. Let's give them more appropriate titles. So we can drag a select tool onto the canvas and we can simply put Month as the rename for Name2 and we can put Sales as the rename for Value. Adding a browse tool after the workflow and rerunning it will produce a very neat output ready for onward consumption. Now it's worth pointing out how the data types are treated when it comes to the new columns. If a field is numeric in nature, then Alteryx will provide the column with a data type that is the shortest possible value after considering the longest value in the column. If the new column has a mix of numeric and string values, the resulting data type will be a string data type. Now, depending on how large your screen is, you may or may not have noticed a configuration option at the very bottom of the configuration window. There are 3 options which allow you to specify how you would like the workflow to react if any of the fields you select in the key columns or data columns sections are missing from the input. These are error, warn, and ignore. Errors will stop onward processing, whereas warn and ignore will allow Alteryx to continue processing records. I always feel it's best to set the missing fields configuration to warn over ignore, as having feedback is always better than having no feedback at all. So to summarise, you can picture the key columns as the columns for which your data is anchored to. They do not change. The data columns will be consolidated into 2 columns. If you are familiar with Tableau data sourcing, the Transpose tool is very similar to performing a Tableau pivot. And if you're familiar with Python programming, you may have utilised the pandas melt function, which also enables us to transpose data into a long format. In this video, we'll be taking a look at a transform tool known as running total. The running total allows us to calculate a cumulative sum per record from an incoming dataset. So let's dive straight into some examples. To illustrate this, we will drag in an input tool onto the canvas and we'll connect it to our city populations dataset. In the preview window, you can see we have a Banda on the first row with a population of 192, Abbeville on the second row with 2,688, and so on. Now the order of the input matters, as a running total is performed row by row. Let's now drag a running total tool onto the canvas and connect the output of the input data tool to the input anchor of the running total tool. In the configuration window, we have 2 simple decisions to make. And to start with, we will look at the Create Running Total section, which is the second box. Here, we simply need to state which numeric field or fields we would like to calculate a running total on. Now, seeing as we only have one numeric column in our incoming dataset, this decision is made for us. However, if we had 2 or more numeric fields, we can decide which column or columns we would like running totals to be performed on. Once decided, we can run our workflow, and when we assess the result, you'll be able to see a cumulative sum of the population in a column which is prefixed with run.tot_, followed by the name of the column that you've chosen to perform the calculation on. So we start with 192 on the first row. Then when we add 2,688 to it, we get 2,880. We then add 4,521 to it, and we end up with 7,401, and so on. Now this cumulative calculation will happen all the way down to the very bottom of this dataset. This is because we have not grouped our calculation by any attribute. So let's see what the optional Group By configuration allows us to do. If we were to select State from the top options list in the configuration window, i.e. if we were to group by state, what this will do is treat each running total separately for each different state instance. So Alabama will have its own running total, but when it gets to the next state in the list, the running total will start again. So let's run the workflow to see this in action. So on initial glance, we get the same output as the first workflow. However, notice that when we scroll to the next state, which is Alaska, the running total starts again at 326 for the city Adak, and then the cumulative sum is performed again. So grouping by fields allows us to select parts of the dataset for which we'd like to perform a running total on. Now, as mentioned earlier, and as you can probably tell, the ordering of the incoming dataset matters. If I were to copy and paste this workflow, add a sort tool in between the input data and the running total, and then sort city in descending order, when we rerun the workflow, we get a completely different result, despite the column being called the same. So always pay attention to the ordering of the dataset to ensure you're getting the expected result. A great use case for running totals is when you're working with DateTime information and want to see how values accumulate over time, for example, the cumulative sales or costs over a specific time range. In this video, we will cover a transform tool known as the Summarise tool. Now, the Summarise tool can perform many different functions, but the one thing they have in common is they create some form of summary of your data. Now, this could be through summing data, finding out the minimum or maximum values on a subset of your data, grouping your data, you can perform math functions, the list goes on. So let's run through multiple questions that we may want to ask on a game dataset. So firstly, we'll connect to the dataset called game, where we are presented with a table of information showing a team colour, a player's name, the round of the quiz, and then we have a column for each question that was asked in the quiz. 1 indicates that the individual answered the question correctly, and 0 means they answered the question incorrectly. So let's do some analysis and see what we can discover. We'll drag our first Summarise tool onto the canvas. The first question I want to answer is, what are the different team colours? To answer this, let's go into the configuration window to help us find the answer. As you can see, we're presented with a top section giving us the fields that are from the incoming dataset. So what I can do here is select a column that we would like to summarise. In this instance, I'm interested in the team colour, so I'm going to select this field. I can then click on the Add button here, and we have a long list of Summarise options to choose from. We can group the column by the different valid values in the column. We could count the distinct values that exist. We could find the min or max, which for a string field is not that common to do, but can be done. Now, because we want to find the names of the team colours, I will select Group By as my action. Now, if I wanted to, I could change the column name that will be displayed in my output, but we'll keep it like this for now. When I run the workflow, you can see we are presented with a very small table, 1 column in width, telling us that there is a red team and there is a blue team. Okay, great. Next, I want to find out how many players there are within each team. Now, I'm not interested in their names at this point, but I'd like to see how many players are within each team. Can you think of a way to do this? Well, I can drag another Summarise tool onto the canvas, and this time, not only do I want to group by the column team, but I also want to summarise the players column, and the action I want to perform is the Count Distinct option. We will leave the column names as the default shown here. When we rerun the workflow and observe the result, we can see there are 3 players on the blue team and 3 players on the red team. Great, so we're starting to paint a better picture of the game. Next, I want to see how difficult the rounds were and observe how many times the questions were answered correctly. So I'd like to see for each round how many of the players answered question 1 correctly, and then see how many of the 6 players answered question 4 correctly in round 6, and so on. Take a moment to think how this can be achieved. Pause the video and give it a go. Okay, so firstly, we want to assess each round, so we'll certainly need to be grouping by round. So let's start by applying that. Next, we want to perform an aggregation on our data. We want to sum the amount of times question 1 was answered correctly. So we can select question 1 column, and then add an action to sum this column, and group by round. In fact, I can also add question 2 through to question 6 by selecting them all and then adding a sum operation. So I'll be summing all question columns and grouping by round. If you're familiar with SQL and understand how and when to use the group by function with aggregations, consider this operation as the same thing. When we rerun the workflow, we get a result set which summarizes this. I can now easily see that in round 1, 5 out of 6 people got the question right, and in round 6, 3 out of 6 people got question 4 correct. Looking across this whole dataset, I can see there was not one question in any of the rounds that was answered correctly by all 6 players. Now we've only used the group by, sum and count distinct operations so far, but there are plenty of other operations you can perform. If you're not familiar with data aggregations and grouping as a concept, I would recommend taking my MySQL course where we discuss this in plenty of detail in the early sections of the course. Having a solid understanding of data aggregation not only helps when retrieving data from databases, but it helps when aggregating data using pandas in Python or performing analytics when working with low-code or no-code platforms like Alteryx. Now feel free to explore the other actions if you wish, but I won't go into them in detail here. But I do really want to find out the answer to 2 more questions. What team won the game? And secondly, what individual won the game, disregarding the team they were on? Was it the blue team or was it the red team that won? And which individual scored the most points? Using what you've picked up from the Summarise tool and any other transform tool that you know of, see if you can create a workflow which shows the correct answer. If you get stuck, come back and join me where I'll take you through my solution. Okay, so hopefully you figured it out. Firstly, we're going to need to transpose our data so that the quiz scores are all in one column. I would expect to see a column with the question number and then a column with a 1 or a 0 representing whether the individual answered the question correctly or not. So let's drag the Transpose tool across to the canvas and then we will set the key columns to be team, players and round. The remaining columns will be our data columns, which are already defined as such after our key column selection. I then want to quickly change the column headers to question and score respectively. We're now in a position to answer these questions easily. So firstly, what team won? Well, let's add a Summarise tool after the Transpose tool and we'll first group by the team field and then we will sum the score field. Running the workflow, we can see that it was very, very close. But the red team won with a score of 66, beating the blue team by 1 point. Now what individual won? Well, this is the same concept, but this time we need to group by the player field. So let's just change the existing Summarise from team to players. Running the workflow again, we can see that this was also a close result. But Tamara came out on top with a score of 25, and Ali very close behind with a score of 24. So the Summarise tool is a great way of being able to gain insights into your data at different levels of aggregation. If you wanted to use these numbers in your workflow, they can be fed into subsequent tools. You could even join this result set back to the original data with a join tool, which would then mean you can perform even more analytics. Simply feed the Summarise result into another tool of choice. In this video, we will take a look at a transform tool known as the Crosstab tool. The Crosstab tool allows us to create one new column for each new categorical value held in a single existing column. It essentially pivots the data from a vertical layout to a horizontal layout, having the inverse effect of what we saw with the Transpose tool. In fact, we covered the Transpose tool, which turned our tables from a wide dataset to a long dataset, so it turns many columns into one column. Now you can think of the crosstab tool as being a way of being able to take a long dataset and transforming it to a wide dataset, or turning one column into many columns. So it has the opposite effect. So let's dive straight into some examples to understand how it operates. Seeing as we've covered the Transpose tool, I actually want to leverage on this understanding to illustrate the crosstab functionality. So firstly, let's drag in an input tool onto the canvas and connect to our dataset called Game, which we saw when walking through the Summarise tool. Now the first thing we're going to do is transpose this data so we end up with team, players and round as key columns, and then we should have one column stating the question number, i.e. the headers from the data columns, and we should then have another column which states the scores, so either a 1 or a 0. When we run this workflow, our wide formatted dataset is transformed into a long formatted dataset. What we will do now is connect a crosstab to the output of the Transpose tool and try to revert us back to the original dataset, i.e. turn our long dataset back into a wide dataset. This should make it easier to conceptualize what's happening. So in the configuration window of the crosstab tool, we need to set a few options. Firstly, at the top, we have a section labelled Group Data by these values. This will, in a very similar way to any group by function, group the values in the columns you select together so that there is one row per unique observation. So we'll be making a similar selection to the key columns in the Transpose tool, but the result set will show a unique row of observations when looking across all three columns. So I need to select team, players and round in this example. Next, we have a configuration option called Change Column Headers. What this will do is create a new column for each unique value contained within the column that you select from this dropdown. So if we select name in this example, which we know represents the question number in our dataset, we would expect to see columns for question 1, question 2, Q3, and so on. The third configuration option is called Values for New Columns. So far, we've decided what to group by and have decided on what column values to take as our headers. But we now need to stipulate the column that will act as the values. So in this example, we know we want to see 1s or 0s underneath each question column. So we will select the value for the new columns to be the value column from our Transpose dataset. Finally, depending on the level of aggregation you've selected in your Group By option at the very top, you need to stipulate the method for aggregating values. In this example, seeing as we are trying to get back to our original dataset by pivoting our long format back into a wide format, we just want to sum the values accordingly and place the result in the respective columns. So this should do us for this example. Let's run the workflow and observe the result. As you can see, when we click on the output of the input data, we have a wide format. When we move across and look at the output of the Transpose tool, our data has been transformed into a long format. And finally, if we check the output of the crosstab tool, we have pivoted our data back to the same format as the original dataset. We have a slightly different ordering, but if we scroll down and take a look at round 1 for Mike, we can see that he scored 1, 0, 1, 1, 1, 1 for round 1. And if we compare this to the raw input, we can see that it states the same. So the reason I'm sharing this is so that conceptually you can think of the crosstab tool as being the opposite of the Transpose tool. You can take a long formatted dataset and set it to a wide formatted dataset. I now want to walk through one more example, which is a little different on a different dataset that covers the concept through a slightly different lens. So we are first going to connect to our tutorial data. And the first thing we're going to do is clean up our gender column so that the special characters are removed from either the male or female valid values. So we can drag in a formula tool, and we're going to select gender from the output column, as this is what we want to address. We then want to type replace, as we're going to use the replace function. And then we are going to look in the gender column. We're going to look up this sequence of string characters, and this will be replaced with an empty string. Okay, so with the gender column cleaned up, what we want to try to achieve is the following. We want to see a final output that shows us each user ID, first name, and last name in 3 columns. We then want a column representing each gender, and then within each gender column, we want to see the email address of each user. Pause the video and see if you can construct the workflow to get the desired result. Okay, so seeing as we want user ID, first name, and last name as our first 3 columns, we are going to select them from the Group Data by These Values configuration option list. Next, we want to select the field that contains the column headers for our new dataset. I'm hoping the data cleansing of the gender field was a big clue, so here we want to select gender. Therefore, we should end up with a final result that has a column labelled female and a column labelled male. Within these columns, we want the values for the new columns to be email. So we're going to select email from this drop-down list. Now in the method for aggregating values, we have 3 options, unlike the previous example. This is because we've decided to include a string value as the value to incorporate for the new columns. Now we can do a couple of things. In the event that there are multiple possible values, which all depends on the initial grouping selection, we can either concatenate the strings together, we can pick the first string value, or we can pick the last string value. Now, seeing as we are grouping by user ID, which is the most granular level with a unique record for each row, each of these selections will produce the same result. So we'll leave it as concatenate for the time being, as I'll show an example shortly when this selection matters. When we run the workflow, you can see that for each user ID, we can see their name and also a column for female and male with emails in each one, just like we wanted. Now I know in this dataset that there are multiple people with the name Josh. So let's only group by first name to see how the concatenate option works. At the bottom here, I can add separators when concatenating. So I'll add a comma and then a space by providing the escape syntax / and then an S. When I rerun the workflow, you can see that for the name Josh, 3 emails were found, and they've been concatenated and have been separated by a comma and a space. Now you don't just have to use a comma and a space. If you wanted a tab, you could use \T, and if you wanted the values to appear on different lines, you could use \N. The separator you use is up to you. So hopefully that was useful in seeing how the crosstab tool works. Just picture it as having the opposite effect compared to the Transpose tool. Make sure you practice turning long formatted datasets into wide formatted datasets to make sure you have this skill in your toolbox. You never know when a use case for it will come up, and you'll be ready to utilize the crosstab tool. In this video, we will take a look at a transpose tool known as the Arrange tool. Now, the best way to think of the Arrange tool is to think of it as a manual way of being able to transpose and rearrange your data. Observing the Arrange tool in action is certainly the easiest way to understand its operation, so let's dive straight into some working examples. So in this example, I will connect to a dataset we've seen previously called tutorial data. Now let's suppose that we wanted to have 3 records for each user ID. At the moment we only have 1 record for each user. Now one of the records we want to show the first and last name of the individual in 2 separate columns. In the second record we want to show date information, so the date of birth and the date they registered. and the final record we want to show contact information, which in this dataset would be the email address only. Now our dataset is obviously not arranged in this way. We have one record for each user ID. So let's drag in an Arrange tool onto the canvas and tweak the configuration to bring back the desired result. Firstly, you will notice that we have a section at the top called Key Fields. This operates in the same way as the Key Columns section in the Transpose tool. So the fields you select here will be maintained and will not change. So in this example, we will keep the user ID as a key field as we want a common identifier for each row so we know which user the record pertains to. Now the second section, the output fields, are where we stipulate what fields we want to create and which valid values we want to appear in the respective columns. So for this example, we will first of all start by adding a new column. So we click on Column, then Add. We can then provide the column with a header. So let's go ahead and call this column FN for first name, -DOB for date of birth, -email, which on the face of it looks quite long and confusing, but it will make sense shortly. We can then choose whether we want a description column for each row, or whether we leave out the description column. In this example, I will include one, as it will come in useful to classify our rows. In this column, we want to add first name, birth date, and email. Now let's think about this for a second. We are transposing our data based on user ID. So user ID will be our first column. We are then creating 3 rows of data for each user ID. The first row will contain first name, the second row will contain birth date, and the third row will contain email. So let's click OK and observe the configuration window. Now we are able to swap what valid values appear and the order they appear in, but this order works for us. If we run the workflow and check the result, you can see that we're getting 3 records for each user ID. Our new column is populated with first name, date of birth, and then email. It would be quite helpful if the description column was populated with a classification as to what the row of data represents. So let's quickly do that. The first row is name information, the second row will be date information, and the third row is contact. Okay, great. We now have a field we can use to filter on for specific categories of data. Let's take it one step further and add another column. We will first label this column ln-reg for last name and registration. We want to bring back the last name column and the registration date column. We will actually leave the third row empty as we do not have any more contact information. So at this point, we have 2 new columns created with specific fields from the original dataset. We have ordered them in such a way that the first row shows name information, the second row shows date information, and the third shows contact information. When we run this final workflow, you can see we've created an entirely new dataset, albeit predicated off the incoming dataset, just slightly rearranged for the purposes of onward consumption for our use case. Now this arrangement is not providing a very good output, but the concept remains. We have been able to construct a new output by transposing and manually creating columns in the way we desired. So to summarize, the Arrange tool allows us to stipulate key columns which are not changed in the final result, very similar to the Transpose tool. The values within them will be duplicated if multiple columns are combined into one. The order you select the fields in the configuration window will be the order they are transposed in each row. You have a description field that you can utilize, but this is optional. You don't have to have a description field. In the example I walked through, I used this description field as a way of being able to provide different bits of information with a category, which can then be filtered subsequently to obtain necessary bits of data. Practice the Arrange tool on different sets of data to make sure you understand how it operates and give yourself even more flexibility with data transformation that will enable you to tackle any data problem that is thrown at you. In this shorter section, we're going to look at a couple of the parsing tools available in Alteryx. So what does it mean to parse data? Well, data parsing is a way of taking data of one format, so it could be a string of characters and symbols, and then converting them into a different data format. For example, converting them to a date data type or a new data structure completely. The first parse tool we're going to look at is called the DateTime tool, which will allow us to convert strings or dates into dates or strings respectively. So let's first of all add the parse tools to our ribbon by clicking on the plus icon here and then selecting parse. Now for illustrative purposes, I'm simply using a text input which has multiple columns of date information. I have included this in the resources section for you to be able to follow along on your own machine. So you can see from this input that we have dates in year, month, day format. We have dates written in full month, then day, comma, then year. We have the last save date with month dash day and then a / followed by the year, which is unusual, and then some dates with time information as well. Now let's first observe the data types of each field. So we can drag in a select tool, and this will then show us that our date information is coming through as date data types. We have two strings, a date time and then a time. So let's suppose we want to change the format of the join date field and convert it into a string. The original data type we can see is a date data type. What we can do is drag in a DateTime parse tool onto the canvas. And the first option in the configuration window is asking us to select the format we would like to convert. So in this example, because we know our field is a date data type, we are going to select the date/time format to string. The other option we get is string to DateTime format, but we'll see this in a second. The next selection we need to make is the selection of the date time field we would like to convert. So here we can select the join date field. Next, seeing as we're going to be outputting our newly converted date column into a new column, we need to give the new column a name. So let's go ahead and call the column join date string. The final option to select is the format that we would like the new column to take. For this example, I quite like the format of month, dd, year. So let's select this option. Now we could take advantage of the custom formatting by selecting custom and then stipulating the format that we would like by using what are known as specifiers. Specifiers always begin with a % symbol followed by a case-sensitive letter. Now I've attached a link in the resources section where you can find a list of all the date specifiers to construct your own custom date. So for example, I could put % uppercase A, % lowercase d, % uppercase b, and then % lowercase y, and this will bring back the date format in the following way. I could also write out day, month, dd, then 4y's, and we will get the result formatted slightly differently. So be sure to check out the specifiers if the predefined date formats are not sufficient. So let's change this back to month, dd, then year, and when we run the workflow, you can see we get our new column with the date converted into the format of choice. Okay, great. So let's move on to the next example where we take a string, but this time convert it to a date format. Let's drag another DateTime parse tool onto the canvas, and this time we're going to select the option of string to DateTime format. The string field we want to convert is going to be the last save date, which comes through as month with 2 digits, dash day with 2 digits, / year with 4 digits, which although is unusual, it will not be a problem for Alteryx to parse. Next, we need to specify the new column name, so we will call this last save date new. Now in the select format that matches the incoming string field, if it existed in the predefined list, we could pick one of these. But as ours is unusual, we will select Custom. In the configuration box beneath, we can then specify the format of our string, which in this case is mm-dd/YYYY. When we run the workflow, you can see that we are presented with another column as defined in our configuration, which has passed the string format and brought back a date result. So use the DateTime parse tool to help convert formats of datetimes to your desired output. Having DateTime information stored as such makes for a much easier time when conducting time series analysis and taking advantage of DateTime functions using the formula tool. Speaking of the formula tool, you can also use the formula tool's DateTime functions in order to convert DateTime data into a more readable format, which makes subsequent analysis easier, in a similar way to how the parse tool operates. In this video, we'll take a look at a tool called Text to Columns. Many of you may have used a similar operation when working with Excel. For example, when working with comma-separated value text files, using the Text to Columns function in Excel will allow you to parse the data by selecting a delimiter that separates your values and splitting your data into their own respective columns. Well, the Alteryx Text to Columns parse tool performs the same operation. In fact, you can actually split text from one column into separate rows or columns in Alteryx. So let's see it in action. Firstly, we have some example data that we'll be looking to parse. The data is populated with addresses. Now, as you can see, there are different parts of the address, like the house number, street address, city, and the state and zip information. So let's separate some of this information into distinct columns. So let's drag in a Text to Columns tool and configure it accordingly. In the configuration window, we first need to select what column we are looking to split. Now for us, this is an easy decision as we only have one. So we'll select Address. We then need to specify a delimiter that separates our text. Now in this first example, we're going to split based on one delimiter. So we are going to split wherever there is a comma. So in the delimiters box, we will simply put a comma. Seeing as we want to split this information into separate columns, we will select the Split to Columns option, and then we need to state the number of columns we would like in the output. For us, this will be 3, as we have 2 commas present in the address field, which will split our address into number and street name, city, and then state and zip information. If there are any extra characters, we have a few options to choose from. We can leave the characters in the last column, we can drop them with warning, we can drop them without warning, or we can throw an error. So if there was a third comma which appeared in one of the rows, we will just want this to appear in the third column. So we'll put leave extra in last column for this example. We then need to state what we want the prefix to be in our new column headers. So let's simply put address, which will mean that we will get a column called address 1, address 2, and address 3. When we run the workflow and observe the result, you can see that our address column has been split into 3 new columns. The data has been split wherever there was a comma. So quite a simple operation, but very useful when we want to isolate parts of a field. Now if you look closely, some of the address 3 column is showing the state with a space, then zip info, some of which is separated by a hyphen. So let's cover an example where we use multiple delimiters to split our values into multiple columns. In this example, we're going to be splitting on a space as well as a hyphen. So let's drag another text to column tool after our first text to column tool, and this time we want to split the address 3 column. In the delimiters section, we are going to state that we want to split wherever there is a space, which is done by putting a backslash followed by an S. If we wanted a split where there was a new line, we would put \n, and if we wanted to split whenever there was a tab, we would put \t. Now straight after the \s, we want to put a hyphen as the second delimiter that we want to split on. We will once again split to columns, and we will also want to set this to 3 columns. We will leave the extra characters in the last column like last time, and we will output a prefix of state_zip. When we run the workflow, you can see that not only are we getting a column back with state information in it, which is followed by a space, but we are also getting the zip codes in 2 separate columns, for those which were separated by a hyphen. Now notice that those records which didn't have a hyphen, the third column is populated with null values. So a short walkthrough as to how the text to columns can be used. It's very useful when you're wanting to split a single column of information into multiple columns, which can be split on specific delimiters. Play around with it in different examples to get a full understanding of its capabilities. In this video, we're going to observe how we can export a result set to a database. Exporting results to Excel files and CSV files is great for specific use cases, but it doesn't necessarily lead to the most efficient automated process that you may be striving for. Data that is stored and maintained in a database is much more controllable, as well as scalable. You can create automated solutions that, with one click of an Alteryx workflow, sources data directly from a database, then performs some form of transformation, and then sends the data back to a database. You could then have visualization software such as Tableau that sits on top of the database table with a live connection, which means your dashboards and charts are automatically updated when the new data hits the database table. This can create some really efficient analytics processes, which requires very little manual involvement, once set up of course. So let's see a quick example of sending data to a database and then perform some quick analytics on it using SQL. We will then apply a quick visualization of the data using Tableau to illustrate how efficient updates can be, which we will do by changing our data through Alteryx. So let's begin. Once again, for continuity, we will use the small workflow that transforms the pet store sales dataset, and we'll drag an output tool onto the canvas. This time, rather than selecting an Excel file as our output, we will click on Data Sources on the left-hand side, and then we will select the MySQL database, as this is the database I'm using. Now obviously, providing Alteryx has a connector to the database you're using, you'll be able to connect to it. I can then pick and choose which MySQL data source I'm sending it to. So in this instance, I will send my result to a schema called Sakilla, and I can then establish a connection to the database using my username and password. If you haven't got a connection established, you will need to do so by clicking on ODBC admin and then inputting your connection details. Once I've provided these details, Alteryx will ask us for a table name that we want to store the result set in. So for this example, I will call our table Alteryx_result. Now you can see we have a few configuration options, but the one I want to draw your attention to first is the output options. The first time we create this table, we will need to have this set to create new table, because the table doesn't exist at the moment. Keeping everything else the same, if we now run the workflow, you can see that the 169 records have been written to the database within our new table called Alteryx_result. So let's go across to the database to make sure that this is the case. If I write a simple select star query using SQL, you can see the result appears just as we would expect. Now let's try to run the workflow again. Notice that if I try to run the workflow again, it will not work, as the table name already exists and is unable to create a table using the same name, very similar to what we saw with the Excel file outputs. So before I forget, I want to now change this option to be overwrite table, brackets drop, so that my table is replaced with the new information every time I run the workflow. Now this may not be what you want to do in your workflow. In fact, you may want to append data to your existing database table rather than deleting the whole thing. So it is very much a case-by-case basis in how you configure your output. So be careful in your configuration. You don't want to accidentally delete tables from your database. So use test tables first to ensure the operation is working as per expectation and make any necessary backups of your data. The great thing about using Alteryx to write data back to the database is that you can run pre and post SQL statements that are performed on the database when you run your workflow. So picture this scenario. You have some data that you want to load into the database. The data pertains to December sales. You want to delete all the existing records in the database that pertain to December and replace them with the new ones to be added via the workflow. In order to do this, we can enter in a pre-create SQL statement, which deletes records where date is December. What this means is that the delete query is executed first. The workflow is then run and the new data is appended to the database table. If you had a post-create SQL statement in as well, this would run after the workflow has executed, so you have a lot of control over the database. Okay, so now we have the database table set up, let's quickly create a Tableau chart that displays a view on this data. Okay, so first of all, in Tableau, I will connect to the database where our new result resides. So I can select MySQL as the database and then put in my connection details. I can then connect to the table, which in this case is the Alteryx_result table. Let's just construct a quick bar chart which shows the sum of sales by city. And we will also show a breakdown of each chart by month, and we'll do this by dragging the month column onto the colour shelf. I can see we have a large block here which actually pertains to the total, so let me filter this out accordingly so it doesn't skew the result. Okay, great. I can tell this chart will be useful for others, but I've just been told there is some missing data from the pet store in Douglas. This needs to be corrected. So let's go back across to our Alteryx workflow and make the necessary adjustment. Just before the final output, I'm going to add a formula tool and then update the January sales figure for Douglas to be 1 million higher. An unrealistic adjustment, but one that will certainly show a clear change in the final chart. So we can type if month equals January and city equals Douglas, then sales plus 1 million. Else, for all other records, take the sales figure. We can then end the if statement here. If we now run the workflow, and then go across to the Tableau report we've just created and refresh the database, we have an updated result without having to make any change directly in the database or any change in the final visualization. So although we've touched on databases and Tableau here, I'm hoping this shows how Alteryx can integrate with other software to create seamless automated solutions. If you're keen on expanding your data analytics skill set across all 3 platforms visited in this video, I would love to see you inside my Tableau Fundamentals course, where we go through key functionality and concepts when it comes to creating dashboards and effective visualizations using Tableau. I also have an 11-hour course on database querying essentials using SQL, which will strengthen your skill set even more, leading to efficient automated solutions for you, your stakeholders, and your organization. In this section, we will look at a very important capability: exporting data. Once we've produced a workflow which generates an output of some kind, we may find ourselves in a position where we want to export the result set, potentially in different formats to accommodate different systems or software for onward consumption. The first export method that we'll look at is exporting data to Excel files, and we'll cover 3 common use cases which you may find yourself with. Firstly, we may want to simply export the entire result set to a single Excel tab. So first of all, I have a pre-designed workflow which takes the pet store monthly sales data, transposes it so it's in a long format, just as we like it, and then I perform a quick cleanse and rename some columns to bring us a dataset that looks like the following. Now let's see how we can export this dataset to a single file with a single tab. So here, what we can do is drag in an output tool from the In-Out tool palette. Within the configuration window, we can select the drop-down where it states Write to File or Database, and in this example, we're going to write to an Excel file. Now you can see from this list of files that we have a lot of choices, but the concept of exporting to different file types is very similar. So let's select Microsoft Excel. When we select Excel, we need to give the Excel file that we're about to create a name. So for this example, I will call it Result1 and then hit Save. You should then be presented with a pop-up which asks you to enter the worksheet name, so the name of the tab when it lands in Excel. So let's call this tab Pet Data to make it clear to see. When we run the workflow, you can see the workflow runs successfully. And if I go to the directory where we saved the file, we have a new file called Result1, which we can now open and then perform any analytics that we want within this Excel file. We can distribute the Excel file in email to your recipients of choice. Now notice here that if I try to run the workflow again, we run into an error which states that the sheet already exists. This is because in the configuration window, we have set the output options to be Create New Sheet, but because it exists, we run into this error. To avoid this message, we can either save the file with a new name, or if we want to overwrite the previous file, we can change this selection to Overwrite Sheet (drop). When we now try to run again, we get a successful export, which has overwritten the previous version. Now let's take this one step further. Let's suppose that we want to export our results to a single Excel file, but this time we want to separate our results into different tabs with labels that make it easy to observe what dataset is which. Now let's quickly look at the result set to see how we can split this data. Let's suppose that we want all of our data in one Excel file, but for each city that exists in the city column, we want the results to be in a separate tab, with the tab name equal to the city name. This is so when we circulate the sales data to each city, they can easily identify the tab they need to look into for their data. In order to do this, we can perform a dynamic output by combining the use of a formula tool with the output tool. So let's go through the process. Firstly, we need to create a new field using the formula tool so that we can assign each record with a place to be exported to. So we'll create a field called File Path, and we will set this equal to the name of the path that we want the Excel files to be placed in. So in this example, I will place the result in my C drive, put a colon, backslash, then users, backslash, then my username, backslash, then Alteryx, backslash, then Excel outputs. I will then end with a backslash. I can then concatenate a file name, so we can put plus and then enter the field name city. We can then put a plus and end with .xlsx. So at this point, each row in our final result set will have a new record with a file path. This will be used to tell Alteryx to export the result to this file. To provide the tab name, we will also need to provide this, which can be done by placing a pipe symbol after the XLSX, which can usually be found to the left of the Z character on your keyboard, and then we can put plus and then the field city. seeing as the file itself will be labelled with the city name, we don't need to do this, but it makes it look cleaner. Okay, so once we've done this, we need to make a couple of tweaks in our output tool. So what we first need to do is change the output options to overwrite sheet brackets drop. We have to then select the option which states take file / table name from field. You can probably see where this is going. We now need to tell Alteryx the file path that we want the results to be sent to. And seeing as we have a new column which states this information, we can select the option from the drop-down which states change entire file path, and then provide the field in which the file path resides, which in our case is the new field we created called file path. So what Alteryx will do is take the file path name from this column and send each record to the respective location. If we don't want the file path to be in our output, we can deselect the box which says keep field in output. When we now run the workflow, we can see that the files are produced accordingly. And if we go across to the folder in which I saved these in, we get a new file for each city. And if I go into one of the files, notice here that it only contains the data for the city as it's based on the field we created in the formula tool. A very nice way of being able to dynamically slice parts of your results into different files. Now finally, I just want to show you one more example, which not only splits the results into different files, but also splits the results into different tabs. So let's suppose that in each file that is currently based on city, we want a separate tab for each month name. We can simply do this by changing the formula tool to end in month. This way, the file path name will change with a tab name based on month. And if we run the workflow, you will see that it takes a little longer to create all the files. In fact, there will be close to 100 files, if not more, that will be created. But when it finishes running, we can go into one of the files and we can now see that our result set is not only split by city, but we now have it nicely organised into different tabs, one result set for each month. So here are a few examples of exporting data into Excel. A very popular export option as many people are familiar with Excel and can perform bespoke ad hoc analytics on it. Play around with a couple of other options to make sure that you're comfortable using them. The final thing I want to mention is that the Alteryx community is a great place to go if you ever get stuck with particular nuanced export requirements. It's very rare that I go to the Alteryx community to find an answer and walk away disappointed. So be sure to check out the community if you require an answer to an Excel export question. Welcome to this new section in which we will discuss workflow best practice. Now, although this would be regarded as one of the less enjoyable parts of workflow creation, I can honestly say that it's one of the most important. By employing workflow best practices, you are able to create an easy to follow narrative through the use of comments and annotations, which makes it extremely clear what your workflows are doing. Therefore, when you are sharing processes with your team or other stakeholders such as audit, a clearly defined workflow will enable you to easily outline what is happening at each stage or section of the workflow. It also comes in very useful as a form of handover. So in the case that you leave your team to pursue another role, you can easily hand over workflows that you've created that can be easily understood by your successor, providing the narrative and explanations are well documented, of course. We can even make use of a colour palette that enables us to create different colours for different comments, which makes workflows more visual. So even if you have 500 tools on a canvas and you zoom out to see the overall structure of the workflow, colours will draw your attention to where specific operations occur, such as inputs, cleansing, outputs, and so on. So let's quickly take a look at the comment boxes functionality. As the name suggests, this allows us to include comment boxes with text on the canvas that can be used to describe different parts of the workflow. Now, comment boxes can be used to include any information. So you can include a description of a particular section, you can use them to incorporate titles and headers. So let's drag in a comment box which can be found within the documentation tool palette. So to add this to your toolbar, you can click on the plus icon here and then select Documentation. When we go into the Documentation tab, you can drag in a comment box tool. Now remember, you could always add the tool directly onto the canvas by right-clicking on the canvas and going to Insert. You will then find the comment box option within the Documentation option. The text you want to include is put into the text section at the top of the configuration window. The next configuration option is the shape. Now the default shape is a rectangle with rounded edges, but you do have 4 shape options. You have the rounded rectangle, the oval, and then you have the option of no shape, i.e. it will only show text without any border. Next, you can choose from a selection of fonts, font sizes, and styles. You can then choose the text colour. You can choose the background colour of the shape, which is nice to categorise different parts of the workflow. And finally, you can decide how you want your text to be positioned in terms of alignment, with the following options available. The last thing I want to highlight is with respect to comment box position. Now you can drag your comment boxes around the canvas wherever you like, but comment boxes can also layer on top of each other. So if I were to add another comment box onto the canvas and make them overlap, I am able to decide which one appears in front of the other by right-clicking on the comment box and selecting the option of Bring to Front or Send to Back, depending on my need. So try to get into the habit of incorporating neat explanations and descriptions as you progress with your workflow creation. Not only will it help you if you revisit a workflow after some time, but it will help others as well, as workflows can become very complex very quickly, which makes things very confusing. In this video, we're going to look at a way of being more efficient with workflow creation. Now picture the scenario. You input a large set of data and you add a few tools to it. You run your workflow and the data is then read in, transformed and then outputted. The data set is quite large, so it actually takes around 5 minutes for your data to load and for the workflow to run before you see any results. You then want to make a small tweak to a formula tool you had included. To see the result again, you run the workflow, waiting another 5 minutes for the data to load. This is not a great use of your time. Luckily for us, there is a way of being able to run a workflow whilst at the same time caching the dataset. This essentially means we lock the dataset in memory so that when we run the workflow again, the dataset is already sourced and it will just require the remaining parts of the workflow to run, leading to huge time savings when incrementally building up on our workflow. If the underlying dataset changes, we would of course need to recache the dataset so that the new data feeds through accordingly. Now this is very easy to do, so let me first of all connect to a dataset that I've created to simply illustrate the benefit of caching data. If I connect a browse tool to the input data and then run the workflow normally, we now have to sit and wait for the dataset to load, which although won't take too long, it will take around 2 minutes in total. Some datasets can take a significant amount of time, depending on the amount of rows and columns that are present in your data source. Fortunately, I have the ability to speed this process up with the power of fast forward. So let me bring us to the point where we can see how long it took to load. Now, if we add another tool to the workflow, let's suppose we just wanted to deselect a column of data by using the select tool. In order to see the new output, we would need to run the process again. Now this time, however, we will run the workflow but cache the input data. To do this, we can simply select the inputs, In this case, we only have one, but if we did have more inputs and we wanted to cache them, we could simply press Control and then select the inputs we wanted to cache. We then right-click and select the option which says Cache and Run Workflow. This will take a similar amount of time as we saw on the first run, but when it's complete, you will notice that the cached datasets have a blue bubble around them. So let me fast forward this data load quickly. Okay, so now let's make another change. So let's go into the Select tool and relabel a column. When we now rerun the workflow, you can see that the workflow runs in seconds, saving us a significant amount of time. So caching datasets can help us save a lot of time if we want to iteratively build up our workflows using big datasets. We can add more tools to the canvas, and the cached dataset will get used every time we run the workflow. Very efficient. Now remember, if you change the data input configuration, you will have to cache the result again. In fact, Alteryx warns you of this when you click on the data source, as you will have to click Continue in order to make any data input changes. In this video, we will take a look at the tool container, a very nice feature which allows us to group parts of our workflow together, giving us more control when it comes to the execution of workflows. Tool containers come in useful for numerous reasons, so let's dive straight into some use cases to see them in action. Firstly, you are able to group parts of your workflow together, i.e. you can place multiple tools into a single container. This can be done in two ways. So in this example, I have taken the workflow we created when we transposed data. So we have a stream of 6 tools. Now we can drag a tool container onto the canvas, which then provides us with an empty container, and then we can drag our selected tools into that container. The container's size will dynamically change to accommodate the tools that you've dragged in. This goes for additional tools that you drag in. The more tools you drag into the container will just adjust its size to accommodate the new tools placed within it. Another way to group tools together is to select the tools we want to place into a container, right-click, and then click on Add to New Container. This is great for a couple of reasons. When you move a tool container, all of the tools within it will then move together. So you don't have to worry about individually selecting tools that you want to move in sync. A tool container takes care of this for you. Secondly, when a tool container is enabled, the workflow will run as normal. When a tool container is disabled, all of the tools within it will not run. This therefore gives us control as to what parts of the workflow we want to run, but more on this shortly. Now in terms of the tool container configuration, we have a few options. Firstly, we can label our tool container. This will then make it easier to understand what the container relates to, rather than simply giving the container a number. We then have some styling options. Firstly, text color, which refers to the caption color. We have the fill color, which is the background color of the tool container itself. We can change the border color of the container. We can adjust the transparency of the container. Now the higher number you place in this box, the more transparent, and this goes up to a number of 80. And the lowest I believe you can go to is 1. You then have the option to adjust the margin of the container, i.e. how much space is between the tools and the container border. So if we change this to extra large and then run the workflow, you can see the container gets a lot bigger, as it has a bigger margin from border to the tools. Now, as mentioned previously, sometimes you may be working on part of a workflow that you don't want to run. In this case, you can place your tools in a tool container and then disable the container. This is done by clicking on the toggle icon in the top left-hand corner of the container. Another way to enable and disable the container is by clicking on the Disabled checkbox in the configuration window. When a tool container is disabled, the tools contained within it do not run. Now, being a visual person, I personally love to make use of tool containers to make things extremely clear in terms of workflow layout. Therefore, I always take advantage of the style options that come with containers. I associate specific colours with specific tasks, whether that be inputs, transformation, outputs, and so on. Depending on the workflow, my use of colours for a tool container may change. So the more you use them, the sooner you'll find a pattern of use that works for you. One final thing to cover is that tool containers can contain other tool containers, so you can enable and disable subsets of a container if you so desire. So you have a lot of flexibility in how you want to arrange your workflow. There is not one correct way of doing this, and you will find a preference that works for you, but utilizing tool containers will give you more control over the execution of a workflow. In this video, we will take a brief look at the Explorer box. Now, the Explorer box allows us to display web pages, file directories, or even a file on the canvas itself. So let's first of all drag in an Explorer box onto the canvas. In the configuration window, we can include a URL to the respective web page, directory, or file. So here, I will put a path to the Alteryx directory, which for me is my C drive, then program files, followed by Alteryx. When we click back on the canvas, you can see the directory appear. Now we can use this directory as we would in any usual scenario. So we can double click on a file in the directory and it will open up in the default program of that specific file. Now we are also able to hide the address bar that you can see at the top here with the second configuration option if you wish to do so. Simply check this box here. Now in terms of specific file types that can be displayed, this is available for HTML files, PDF, text, and XML files. So using the Explorer box is a nice way of being able to see that file structures are as you expect them before running a workflow, and can also act as a nice shortcut to access files directly from the canvas, as opposed to opening up new windows and programs, keeping things nice and neat. When building workflows, it's important that you incorporate controls and validations throughout the design to ensure that it performs in line with expectations. Any checks or controls you want in place should be automated as much as possible, so that if anything goes wrong or doesn't work as expected, as a user, you are alerted accordingly. So let's picture the scenario. You're in charge of managing the results of a quiz game. You have previously created a workflow that works out the winning team, for which prize money is then handed out, so it's an important workflow. Now the workflow you've created looks something like this. You source the input data from the quiz night, which is sometimes handed to you in different formats, which you then union together. You then transpose the data so that it's in a long format. You then place a select tool after the transpose tool to rename a couple of the columns. There is then a small formula tool which allows some manual adjustments to be made to the scores if required. The final part of the workflow summarizes the dataset so that it groups by team and then sums the score. This generates the final result, which is then shown within the final browse tool. Now the quiz manager has been a little disappointed with this workflow recently for two reasons. Firstly, prize money was handed out to a team other than the blue or red team last week. In fact, it was handed out to a gold team, which was a fake submission. Unfortunately, the workflow didn't spot this new team. It is expected that players can only represent either the red team or the blue team. Secondly, the workflow has been accepting null data. It is expected that a question is either answered correctly and therefore obtains a value of 1, or is answered incorrectly and obtains a value of 0. So let's run the workflow and observe the result. As you can see,
When we click on the final Browse tool, we can see that, as per the manager's concerns, the goal team looks like it's won again. If I also click on the output anchor of the formula tool, you can see that Mike has a null value present in round 1, question 4. So with these two concerns in mind, let's implement some control checks to ensure they are captured accordingly. I first want to include a control which checks that there are no null records present within the column labelled score. If there is, it implies that the user didn't get the question wrong or didn't get the question right, which we know is impossible. This is a data quality issue we want to catch straight away, so let's implement this. So in order to do this, we can drag in what is known as the test tool, which can be found within the developer tool palette. So we can click on the plus icon and then add the developer tool palette accordingly. We can then drag the test tool after the final formula tool. To add a test, we can click on the add button within the configuration window. We can then provide the test a name. So we'll call our first test null records check. We can then state which input we are looking to perform the test on. Now, seeing as we have only connected one input source into the test tool, we only have one input to select. Now we can pick between 4 test options. We can perform a check that the records count matches a specific value. This is great if you have an expectation as to what the records count should be at specific points of a workflow. If the records count differs from the specific value that you stipulate, then an error will arise and will need to be rectified before continuing. The second option is where record count matches another input's record count. This ensures that there are no duplicates or data being filtered unexpectedly throughout your workflow. You would have to have a second input connected to this test tool in order to use this test. The third test option is where we check that an expression is true for all records. And the fourth check is where an expression is true for the first record. Now, when we are checking for null records, we want this to be done for all records. So in this example, we will select the third option. We then need to stipulate an expression. So I'll click on the little ellipsis on the right hand side, and then we can first of all take advantage of the various functions available in Alteryx. So to test for null values, I can scroll down to the test functions and we can use the one which states is null. I can then enter the incoming field called score in the parentheses. Now, because we're checking to see if the values coming through are not null, I will precede the function with an exclamation mark, which essentially turns this function into an is not null function. So in short, if a record in the incoming dataset has a null value in it, it will be flagged as false and an error would occur. Only when a record evaluates to false will an error arise. So let's run the workflow to see if we've captured the null value accordingly. When we run the workflow, you can see that we get an error appear within the test tool. And if we go to the results message window, you can see that we are being notified that the test null records check failed on record 4. If we now go to the incoming dataset and check record 4, we can see that this record does indeed have a null record, so we can now correct this accordingly. If I go back to the formula tool and change the conditional statement to apply a 1 to Mike's round 1 question 4, implying he got the question right, when we now rerun the workflow, the test has passed and we're now able to continue accordingly. Therefore now, I'm able to feel comfortable that whenever a null value appears in the score column at this point in the workflow, our test tool will capture this correctly. Great. Now you can have multiple tests within the same test tool if you're performing multiple tests on the incoming dataset or datasets. So we'll now address the second concern of management, that it should only be the red team or the blue team that should win the prize money. No other team should win. So we'll add a second test by clicking on the add button, and this time we will call this test team check, which will make sure that each submission is either on the red team or the blue team. So in a similar way to the previous test,
we'll make use of the test type expression is true for all records. We will then include a conditional statement that states if team equals red or team equals blue, then assign the boolean of 1, else assign 0, end if. 1 in this statement can be read as true, and 0 can be read as false. With this check in place, we should get an error if ever there is a submission to a team other than the red or blue team. So let's run the workflow and observe the result. When we run the test, you can see that we get an error stating that the test team check failed on record 253. So if we go into the incoming dataset and scroll down to record 253, we can indeed see that this is where information pertaining to a gold team exists. So let's go to the start of the workflow where the new submission was unioned to the main dataset, and we can close the tool container so that it doesn't run, i.e. it won't be unioned. When we now run the workflow, we get no errors, meaning that the final result will show just red or blue and there will be no null values appearing in the score column. Great, so we've now added more control in our workflow to ensure it operates in line with expectation. Now there is a configuration option at the bottom which states don't report errors if there are other errors in the workflow. Now I usually like to have this deselected, as reporting errors in tests means you can look at them in parallel to resolving some of the other workflow errors, if there are any, but the option is up to you. Now obviously these two examples are tailored to this dataset and are controls you may want to put in place based on the management's feedback. But the types of controls will really depend on what your workflow is trying to achieve. So ask yourself, what should I be controlling at different parts of the workflow? How can I gain comfort that the workflow is producing the correct result every time? If I were to perform manual checks after the workflow, what would they be and how can I automate them using the test tool? Try creating a small workflow and create tests to make sure it's operating as you would expect it to. Now remember, if your test fails, i.e. it generates a false result, your workflow will create an error and you'll be notified where that error has occurred, which then enables you to investigate and correct the workflow accordingly. A very nice control feature, which is important in giving you, your stakeholders, and your organization comfort in your processes.
In this video, we'll take a look at what to expect in the Alteryx Designer Core exam. Now, although it's not compulsory to get yourself an Alteryx certification, getting one validates your knowledge and can act as a nice way of ensuring you're brushing up on key Alteryx tooling. Now, you can for sure still be an Alteryx expert without a certification, but having a stamp of approval is a nice way of recognizing your efforts. For those of you who are interested in getting certified, this video will let you know what to expect. Now, firstly, there are 4 levels of certification that Alteryx offers. You have the Alteryx Designer Core, you have the Alteryx Designer Advanced, the Alteryx Designer Expert, and finally the Alteryx Designer Predictive Master. The first 2 levels, the Core exam and the Advanced exam, are free for anybody to take. But just because they're free, you should not take them lightly, as you do need to know all of the required tools to be able to pass. If you think just because they're free, they'll be easy, you'll just end up wasting your own time, which isn't fun for anyone. I want to start by saying that the content covered in this course will enable you to pass the Designer Core exam, which is intended for everyone. Now, you could be a beginner in analytics or a professional data scientist with 20 years experience. There are no prerequisites for taking this exam, but passing the exam is required for the advanced level exams. Now, the reason it's called the Alteryx Designer Core Certification Exam is because it tests your knowledge of the core toolset in Designer and your ability to apply your knowledge and use the tools to solve real-world problems. The core toolset includes the tools that are most often used in Alteryx Designer and are fundamental to data preparation and analysis. These being the following on screen. Now you will get 2.5 hours for the exam, which is done entirely online, and the exam tests on the 22.1 version of Desktop Designer. You will get one attempt every 7 days, so even if you fail it once, don't panic. Simply brush up on the content and give it another go 7 days later. There are 80 questions in total, and the questions are of different types. You get multiple choice, practical application, matching, and multiple response questions. There is 1 point for multiple choice, matching, multiple response, and practical application questions. There is partial credit awarded for matching and multiple response questions. Now, it goes without saying that you may not receive assistance from another person or allow another person to take the exam on your behalf. After all, you'd only be cheating yourself. For more information on the Alteryx certification agreement and policies, check out the link in the resources section. If you are successful, which I have no doubt you will be, you will receive your Alteryx certification and badge within 48 hours of passing the exam. Every user will receive an email from Alteryx's virtual badge partner, Credly. It's worth noting that a Credly profile is required to access the course certificate and virtual badge that can then be shared online. Now, once you've passed the exam, don't get complacent and think you've mastered it forever. The Alteryx Designer Course certification expires after 2 years. So when 2 years comes around, you may retake and pass the Alteryx Designer Core exam, or you can pass the Alteryx Designer Advanced exam to renew your core certification. There is a practice exam online that I've attached in the resources section for you to get an idea as to what to expect, so there should be no surprises. I've also attached an exam preparation guide which highlights the expected knowledge that you should have before embarking on the exam. A great way of getting yourself ready is to participate in the weekly challenges on the Alteryx website. I've also attached a link to this in the resources section. Remember, understanding the concepts and how the tooling works is far more important than getting the certification. So make sure you put more effort into learning the tools than simply obtaining enough knowledge to pass the exam. You'll thank yourself for it later in the long run. If you do decide to embark on the qualification, feel free to reach out if there's anything you need from us, and good luck with your preparations and the exam. Firstly, I just want to say a huge congratulations for reaching the end of the Alteryx Essentials course brought to you by the Industry Portal. It goes without saying that we've covered a tremendous amount of material, so really well done for getting this far. By covering and understanding the content in this course, you are well on your way to becoming an expert in data analytics and have obtained a new skill set which can be applied in many different scenarios. You've learned data techniques that help you in data sourcing, data preparation, joining data, and transforming data. We've also covered some workflow best practices that will help ensure your workflows are easy to understand, follow best practice, as well as being controlled, giving everyone peace of mind. I'm so glad you've got to this point in the course, and I wish you all the best in your onwards journey into the world of data analytics. If there is anything the Industry Portal can do for you, please don't hesitate to reach out to us at theindustryportal.com. For now, enjoy connecting with other data enthusiasts, and I look forward to seeing where your analytics journey takes you next. All the best, and as always, keep learning, keep growing, and we'll see you next time.